welcome to this 6-day online uh, AICT sponsored ATAL FDP program. Our resource person, uh, Professor Dr. Sisir Kumar Sahu, has joined. Now, this is my responsibility to introduce our resource person. Professor Sisir Kumar Sahu is currently working as professor in HAG in Department of Civil Engineering in National Institute of Technology, Rourkela. In addition to this, he has additional responsibility of chairman, press and public relations, and local coordinator, GIN of the institute. He has served as head of the Department of Civil Engineering, dean, planning and development, and chairman, board of trust, board of trustee of the institute, and chairman, library of the institute. He received his PhD in aerospace engineering from IIT Kharagpur on the area of dynamics of composite plates and cells, and did his postdoctoral research at ISBR, Southampton University, through Indo-British UKRI Fellowship. He has supervised 12 PhDs besides numerous MTech and BTech projects in structural dynamics and waste management. I kindly request the participants, please mute. I kindly request the participants, please mute. Madam, please mute. He is the author of more than 110 publications with nearly 77 peer-reviewed international journals, with SCI Scopus indexing with 1500 citations and an H index of 23 dealing with mechanics. He has written 4 book chapters. He has been granted a patent on fly ash angular aggregates. He has handled research projects on structural dynamics of composites and innovative fly ash utilization for structural applications. He has developed a structural dynamics laboratory with state-of-the-art FFT analyzer, UTM fatigue testing machine, Instron 8862, along with composite fabrication test setup with nano fillers. He has delivered keynote address in many conferences in Germany, UK, Singapore, Hong Kong, Indonesia, etc. His teaching interests include structural analysis, finite element method, plates and cells, and composite structures. His main research interests include structural mechanics, finite FEM, dynamics, stability, fracture mechanics, plates and cell structures, including nanocomposites and waste management. So I, on behalf of Department of Civil Engineering, Synergy Institute of Technology, Bhubaneswar, I, Dr. Pankaj Kumar Das, welcome our speaker, Professor Dr. Sisir Kumar Sahu sir, to this online FDP, and I request sir to give his exposition in the topic which is our topic of the faculty development program. So I again welcome sir to this program. Thank you, sir.
Thank you for the nice introduction. So, should I start?
Sir, namaskar.
Namaskar. So, let me start sharing the PPT.
टाटा CS TCS में એનું સિલેક્શન બતાવે છે અને એવું બતાવે છે કે આને બેકલોગ ચેક નહીં ચેક કરો ને
Is it visible?
Yes, sir.
My PPT is visible, right?
Yes, sir.
Mm, okay. So it's time 6:28. So basically, my talk will be on FRP composites, fiber reinforced polymer composites, and advanced materials for structural applications. So commonly people tell it as a fiber material because of its inherent composition. But I'll tell you exactly the definition itself. So this is the FDP on revolutionizing construction sustainable advanced materials. So participants, please mute yourself. तो lot of
मोशन तमें म्यूट कर दो ना समझते हैं
so you could able to listen me. Dr. Pankaj, you could listen me.
Yes, sir. Yes, sir.
Okay, so let me start.
चलो चलो और घरे पहुंचे
Composite material is an engineered combinations of material which is a combination materials, two materials combinedly and making it the composite, and at a microscopic level the constituent materials remain distinct within the finished structure. So that's the composite material evolved from that one. In fact, this is one of the greatest invention of the 20th century. Why I am telling this? The composites was there, but actually the development has taken place recently. So FRP composites, the history of composite materials has come from the initially there was the stone age, tools and weapons were all made of stones. Then comes the natural composites, wood, bamboo. You might have seen wood or bamboo. If you cut it from one direction, cutting is easily. When it is cutting in other direction, it is difficult. So that's the means it has a two different strength in both direction, like the composite. So these are actually composite materials. There are other composite materials as well. So metals, copper, then comes copper, bronze, iron, aluminum, then comes polymers, ceramics, composites. One of the normally rural used this straw reinforced clay bricks is one of the composite material as well. Then comes the iron for reinforcement of masonry. Reinforced cement concrete is a composite material where actually we can use the um, normal cement concrete as the matrix and the reinforcement as the fiber. So in fact, nowadays even fiber reinforcements are also come up. Then comes fiber glass boat in 1942. It is also started being used in aircraft. It is again used in missile applications in 1946. Then comes carbon and boron fibers. These are still developed fibers. Comes in 1960. Advanced composite in aircraft started using in 1968. Kevlar fibers comes in 1973. Actually, 1980 to 2000, there are significant applications in many areas. So further developments in composites comes in sandwich composites, nano composites, fiber metal laminates, functional graded material. These are some of the developments of the composites. So FRP composites are made from a polymer matrix with reinforcing fiber. People talk of fiber material. There are glass fiber. One is fiber. The second you can see in the right side is polymer. These are the two main materials which constitutes the composite material. The material can be a natural fiber like jute, flax, cotton, or it can be a synthetic fiber like glass, carbon, aramid, or Kevlar fiber, or hybrid means multiple fibers used in one composite. That is hybrid fibers. So similarly, polymer materials are the normal most used in the epoxy, which we everybody know. Then comes polyester, polyethylene. These are the polymer material or the uh, polymer and the reinforcement. These are the, so you can, it looks like this one. Inside the polymer, the reinforcement is there. The main applications is aerospace structures is essential. Automobile engineering, nowadays you might have seen that a lot of cars are coming, new cars are coming, people are coming, fiber body. These are only composites only. Nuclear sector, marine engineering, civil engineering, sports goods. Civil engineering, lot of roofs are being made of glass fiber roofs. Sports goods, lot of tennis racket, cricket bat are made of this composite material only. The latest the materials are composite only because of certain advantage I will discuss you subsequently. The other industrial fields also it has used subsequently. The properties of composites, it is lightweight. Steel is there, aluminum was there, but steel is strong, but aluminum is light. Wherever we need both, we look to the composites. It's lightweight and high specific strength and stiffness. Specific strength means strength per unit weight. Its strength is not high, but specific strength is high. Specific stiffness is high. Low density, high corrosion resistance, longer durability, high internal damping, low maintenance cost. These are some of the advantages of composites. The tensile strength of composites is 100 times greater than that of steel or aluminum. The strength to weight ratio of FRP is 18 times of the steel and 50 times that of concrete. FRP materials are 30 to 40% lighter than aluminum structures. Besides, most of the military aircrafts are composite actually. Besides military aircraft like F-35, Boeing 787, Airbus 350 and above, 350, 380 passenger planes uses more than 50% of composites in wings and its main body, which is the circular body, is called the fuselage and other components in comparison to Boeing 77 models. So Boeing's, in comparison to Boeing 777, 787, which was recently the accident was there. So that uses 50% composite material, minimum 50% composite material. The composite bridge in Oxford, the Avantime passenger car, canoe truck, the award-winning Oracle sailboat are some of the applications of FRP composites. The F-35 Lightning II, the latest aircraft in USA, will be the first mass-produced to integrate structural nano-composites. First composites, then we'll go to nano-composites as well. So some of the nanomaterials are put inside the matrix in non-load airframe components. Meanwhile, one of the nano-composite is the carbon nanotube. Reinforced material is being considered to replace components made with other composites or metals throughout the F-35 airframe, which is the latest aircraft, military aircraft. You can see some of the left side is the Avantime car, which is a more than many portions are composite only. Right side is the roof. It's a glass fiber roof. Then left side bottom is the Singapore airport. You can see a lot of composite material being glass, especially in civil engineering, a lot of glass fiber composites are being used. And this is a composite canoe truck. So these are some of the uses of composite material. This is the Boeing 787 Dreamliner, which India has nearly 50. Air India has 50, but Indigo has also some of the 787. You can see this diagram show you the different parts of the composite. The main body part is called the fuselage, and the wings are made of composites. Here is called the small portion is aluminum. You can see by comparison, the 777 uses 12% composites and 50% aluminum. In comparison, 787 uses 50% composites. More than 50% composites are being used in 787 onwards on most of the military aircrafts. This is the Airbus 350. 350, 380, full composite wing and fuselage panels. Fuselage means the main body. Circular body, cylindrical body, fuselage panels made from carbon fiber reinforced polymers. So this is the Oracle sailboat, which is the owner of 33rd America's Cup. This is the micro air vehicle. It looks like a small fly, but it is a micro air vehicle with small remote controlled aircraft with camera and image recognition software. The micro weighing just 3 grams and measuring 10 centimeter is being used for different purposes, including spying. This is also a teeny micro air vehicle used to detect environmental hazards. This is developed in Harvard University, a 3 centimeter wingspan, flapping wing boat. This is the Israel drone. We have around 50 of this Israel drone. Now seeing that lot of drone around in every institute, competitions are drone involving drone. This is the full scale drone. Used a military drone. This is a military drone we have acquired from Israel. These are small drones. 9 Ukraine nationals detained in Tamil Nadu in 2016 to take photos of the Tirumalai temple. Now we are seeing a lot even in Jagannath temple. Lot of drones are every fortnight something is coming of flying drones, or many parts are composite materials. Drones fly at an altitude of 50,000 feet and can monitor the movement of objects as small as a football. So now you can see also these gas cylinders. Gas cylinders are also become lightweight, unlike the iron cylinders. Now composite cylinders have come off, which are lightweight and non-explosive. So every field it has come up. Vehicles are there. So this is another one which is called schematic presentation of fiber metal laminate. Means one layer is fiber, another metal is metal. So one layer is composite, other metal is either steel or aluminum, mostly aluminum. So we have worked on it. So all these you are seeing, these are everything is, we have worked on this in our laboratory. So this is glass laminate. One layer glass composite and other layer is aluminum. This is carbon fiber, aluminum, carbon, glass, and aluminum. All these three are here. So what we get benefit out of this? You can see a vehicle of the early 1950, first commercial car body. We got, and this is one of the latest car. So we got the design freedom. We got the corrosion resistance, low weight, significant utilization on unique design models can be obtained by the innovation, by the use of the composite. You can see old cars with this kind of base and body panels, and the truck beds with iron beds, and this is the plus fiber bed. So the now body panels, valve covers, stroke beds are corrosion resistance and design freedom, low weight. So these are the development of the in automotive range. This is the heavy truck, initial 1960 truck, and this is the latest trucks. So now 90% of the heavy trucks are composite body. So the advantage is same. It can resist high heat, durability, corrosion resistance, and low weight. 1980, as regards the turbine highest was 15-meter diameter, and it could deliver 50 kilowatt. Turbines were there. Now we could manufacture 150-meter diameter turbines which can deliver 7.5 megawatt of power. That's the level of, due to the composites, it's possible, high strength, low weight. This is also the coming to the airspace. 1970 Concorde was a 8% composite, now 787, 80% by volume, 50% by weight. Besides this, we are having also some of the composites are also used for civil engineering member strengthening techniques. We can use it as a composite material directly, or we can use it for strengthening purpose as well. You can see a civil engineering column which was yielded is being wrapped with carbon fiber wrapping to strengthen the column. This is also, we can give FRP jacket, either we can give a concrete jacket. These are some of the different methods of column strengthening. Either you can give a column jacket, or you can give a steel jacket, or you can give a FRP jacket. FRP jackets, the advantage is there is no load coming onto it. It's very less load in comparison to steel jacket and the concrete jacket. So basically the weight of the structure will not change. Very minimum changes are there, unlike the concrete and the steel. Beam strengthening also we can do methods of beam strengthening, additional layer with the new steel, or we can give CFRP applications to the same effect. For bending, for shear. In fact, FRP bars are also coming into the market. Just like steel bars, FE 415, FE 500, when FRP bars comes into market. These are some of the FRP bars, CFRP, GFRP bars, FRP shear reinforcement. So FRP belts are being used for strengthening purpose. These are some of the tests we have conducted on the beams to strengthen the beams, putting different schemes of FRP, different schemes means putting at the center, putting at the bottom, putting at the top, hole wrapping. So different. So when these are some of the uses of composite structures, but today I will focus mostly on composite dynamics. What is the importance of the dynamic analysis? Static analysis is done when loads are slowly applied, but when loads are suddenly applied or variable in nature, the mass and acceleration effects comes into consideration. If a structure deformed elastically and suddenly released, it vibrates about its equilibrium position. In fact, when I reached 25 years back, no, 27 years back, when I reached Kharagpur, so for my PhD, then I have been told to work on this vibration. But there actually I worked in vibration and stability, same thing I'm working is here, but the only difference is I have whatever I have done in computational. So I have last 25 years, I try to use it for the development of composites and the experimental part of it. The experiment facility that time in the aerospace department was not there. Of course, there was some testing facility was there in the mechanical department 27 years ago, but but even manufacturing of composite, all those things, manufacturing and composite was not there in aerospace. Even these vibration tests were not there. So all these things I have tried in last 27 years, and I will show you some of the things which we have tried here. So all the whatever you are seeing is has been done in our laboratory. This periodic is called pre-vibration. Pre-vibration means when vibrations, to start vibration, we need to give some force, but as soon as the vibration started, there will be no force. The which this that's called free vibration, and if you go on putting force, that's called force vibration. The number of cycles per second is called frequency. The maximum displacement from the equilibrium position is called amplitude. And in practical situations, vibrations subside with time due to damping. If you can see, let me try importance, showing a importance of vibration. This is a breeze which is vibrating in wind. You can see the level of vibration. After few months of this breeze collapses. How much vibration can cause havoc, you can see. How to get out of this? Just a minute. I have to go back to the. I have to go back to the my slide. Is my slide visible?
Yes, sir. Yes, sir.
Yes, sir.
Okay, okay. You can see how is the breeze vibrating, and you can after the collapse, actually this breeze has been replaced by a girder bridge, and it's operational now. That has collapsed within 1 year, and now it is. They have made it to. You can see the everything has been made to girders here, and now the bridge is operational. So the defect is with that system, cable system. So these are the what I tried to show is the importance of the vibration. So our main study is dynamics of composite material. So we have studied vibration and stability of FRP composite. Then we have studied further delamination in composite panels. Delamination means actually composite material is actually, I will show you layer wise fiber matrix, layer wise fiber and matrix. So 4 layer, 8 layer, 16 layer, 20 layer, the layer wise material have been glued. So that way it is actually a composite. So when layer to layer breaks up, that's called delamination. That's called delamination. So delamination also we have studied. So we have studied all the computational, both computational and the experimental. I will show you how we have done experiment on this. So delamination of composite panels. Then composite subjected to hygrothermal loading. Hygrothermal means temperature and moisture. So as you can know, when we are in the airport, we are boarding the aircraft at normal temperature, maybe 27, 28 degree. But when the aircraft is flying, so it is in space, it is minus 50, minus 60 degrees temperature. Though inside the aircraft, the temperature is maintained, the outside temperature is around minus 50, minus 60. So the composites are subjected to different gradings of temperature and moisture. So as I have given you one example of temperature, similarly moisture, sheep structures. So in the moisture content is certainly high. So it has to sustain also that one. So all these things we have studied and tested. So FRP composite, then we have, after the plated structures, then we have gone for FRP composite cells. So then we have studied fiber metal laminates. Then we have studied stiffened composite plates. Stiffened composite means plates. You can see stiffeners are there in horizontal and vertical directions. So stiffeners are there. So we have put the stiffeners, composite stiffeners in the composite structures. You might have seen in the aircraft, if you have you have seen multiple horizontal and circular members are there. So those are stiffeners. So then fatigue behavior of composite plates. We have a fatigue testing machine on which we have studied the fatigue behavior of composite plates. Then composite beam with cracks. So some of the has done with the cracks. Then nano composites. Right now, some of the students is working on vibration and stability of carbon based nano composites. So nano alumina, graphene, these are some of the nano composites. Applications of nanotechnology in construction engineering industry. Addition of nanoscale materials into cement to improve the performance. You might have heard of nanosilica, silica flume. So silica flume is a nano material only. Similarly, carbon nanotubes can also increase in the concrete, in the cement mortar structures to increase both compressive and flexural strength. So nano and micro electrical mechanical system MEMS sensors are used in construction to monitor the environmental conditions and materials and structure performance, means smart material. So advantage of these sensors is their dimension. So these sensors could be embedded in the structure during the construction process also. Smart aggregate, a low-cost piezo ceramic multifunctional device, has been applied to the earliest concrete properties such as the temperature, relative humidity, and strength development. The sensors is used to monitor corrosion and tracking. Now you can see that a lot of discussion being going on the bridge monitoring of the states. Odisha government is now a lot of putting efforts on monitoring of bridges. So bridges, because of they are not accessible properly, so a lot of maintenance has not been, less maintenance has been done. One day it is, when it is falls down or failure occurs, then only people became conscious. So sensors can be put to that, one of the, so that you can think of when the maintenance is required. So this is how it looks like composites. So this is the figure, this is the matrix, and these are all fibers. These are only fibers. Multiple layers can be, this can be multiple layers. Like actually one layer might be 45 degree, another layer can be minus 45 degree, another layer can be 90 degree, another thing can be 0 degree. So these are, it can be any degree. So depending upon, because force is not applied, maybe applied, somebody, some members in tension, some members in compression, somebody is bending, something is, sometimes torque is acting. So this same configuration may not work on it. So we need to make it different configuration based on the requirement. This is a model of the composite plate, multiple layers plate. Each layer is theta. The theta may be different for different layers. So like actually here is 5-6 layers are there. So but each layer, the angle theta may be different depending upon the force it is carrying. This is a cell panel. In fact, all the dynamical studies are studied using the principle called Hamilton's principle. Let's be bit theory, don't go deep onto it. So it's based on Hamilton's theory. So vibrations are all vibration problems are solved analytically through Hamilton's principle. So means kinetic, it involves just static problem, means we find the deformation. We find the, for a particular load, we find out the deformation. And for dynamic load means the first is we find out the natural frequency. So here kinetic energy comes into picture. T is the kinetic energy. Phi is equal to the strain energy plus work done. So either it can be a conservative forces or this can be non-conservative forces. Conservative forces means the direction of the force is same throughout the system. So direction of the force means something is, a plane is going, we are putting a missiles from the ground. So that's a conservative system. Non-conservative system means the direction of the forces vary with time. Means if the aircraft, means with speed of the aircraft, these missiles also follow that one, like torpedo, missiles, interceptors. So they follow, they change the direction of the force system, the missiles itself. So that's called a non-conservative system. So those are when we deal with finite element, mostly finite element analysis has been carried out and experiment has been carried out. So this is the Lagrange equation being used for that. So where kinetic energy is being considered, and so these are the total equations. These are the total equations. M double D plus C per K double D is equal to PT. This is the total equation involving everything. M is the mass matrix, D the displacement, C the damping matrix, K is the stiffness matrix, P is the load. If load is dynamic, then it's PT, or else P. It is just P. P is the static load. So if it is static load, P is equal to K delta. If it is dynamic load, all these things are there. So if you ignore damping, C will be not there. So like that, it one is there. So free vibration equation, Ke minus MQ is equal to 0. So buckling problem, Ke minus PCR Kg is equal to 0, or this is called dynamic stability, means actually it is subjected to a dynamic load. Dynamic load means a building is standing, wind is blowing. Now it is 10 km per hour. During storm, it will be cyclone, it will be 100 km per hour. Every half an hour, the speed is changing. That's dynamic stability. So either the building standing, the load is coming, or the aircraft is going, the load is changing. Whenever the load is changing with time, it's called dynamic load. So we need to, in the finite element, we need to take a element. We have taken a 8 node and 9 node are the 4 node, 8 node, 9 node. These are the various most common nodes are there. We have considered a 8 node, and the corresponding degrees of freedom W, V, U, V, W, theta X, theta Y. U is the horizontal displacement, V is the vertical displacement, W is the bending displacement, theta X, theta Y are the rotations along X and Y directions. When a plate is there, 2 rotations are there. Beam is there, only 1 rotation is there. The overall stiffness and mass matrices are obtained by assembling the corresponding element matrices. This is the element, finite element. So 8 nodes are being shown. This is left side is the composite material. So N layer laminate. This is the strain equation, strain displacement relay equation. It can be linear, it can be non-linear, depending upon the type of problem we are considering. This is the linear displacement equation. Epsilon x is equal to del u by del x, epsilon y is equal to del v by del y, gamma xy is equal to del u by del y plus del v by del x. In addition to this, the bending components are also included here. Z K kappa x, Z kappa y, Z kappa xy, kappa x. So these are the terms included. So the corresponding shear strains are also written, gamma xz and gamma yz. So this is valid for a thin plate as well as thick plate. Composites are usually analyzed using shear deformation theory. This is the constitutive relation. Constitutive relation means stress-strain relationship. If you have a knowledge of finite element, so there is a stress-strain relationship. So the left side, the stresses are there. Right side, the strains are there. In between is called stress and strains. And it all depends. It has a Young's modulus in X direction, Y direction. And similarly, nu in both the direction. And shear rigidity also in multiple directions, it is there. Unlike isotropic material, there is only E and nu. And but composites, all the directions, it is a orthotropic material. In this way, we can find out the value of the Q's and we can put it there. This is the stress-strain relationship, where it's called ABD matrix. In a composite, in the isotropic material, it is multiple of E and nu. This is the stiffness matrix, B transpose dV, Jacobian dj d eta. Xi and eta are natural coordinates. Either it can be in Cartesian coordinates or in natural coordinates. Plate problems and especially composites are done within natural coordinates using these matrices. This is mass matrix, this is geometric stiffness matrix. And we have developed a program using this flow chart. For all, it's for vibration, for buckling, for dynamic stability, everything we have done it. Codes are developed in MATLAB environment to compute the free vibration response of the industry-driven woven fiber, carbon, glass epoxy, composite plates, double curved cells with the area strip delamination exposed to hygrothermal environment. We have done it for plate, we have done it for cell, we have done it for glass fiber, we have done it for carbon fiber, we have done it for strip delamination, and normal temperature, hygrothermal temperature as well. The formulation can handle any geometry, including delamination, material, general distribution of temperature and moisture. From modeling of delamination, multi-point constant algorithm is incorporated in finite element code. Then experimental program. This is you can visualize more better how we conduct experiment in our laboratory. So this is glass fiber or carbon fiber. It can be any fiber. Epoxy, and we take hardener, then polyvinyl alcohol as a releasing agent and we do hand layup method. So the resin is placed along the reinforcement against. So we place epoxy, then fiber. Then if the fibers are industry driven woven fibers, the percentage of fibers to matrix is taken 50 and 50 by what. This can be varied. 50, this can be 55, 45, this can be 60, 40, anything. The woven glass fiber means it's just like our cloth. It is the material is there. This is how it looks like. These are glass fibers. First we put a plastic, then we the oven rubbing glass fiber or carbon fiber, then we put one layer of fiber, then epoxy, one layer of fiber, then epoxy. As many layer you like to do, you can do that. Then we are releasing. This is the top or bottom one is the releasing sheet. Then Teflon film is used for delamination purpose. The small, so these are Teflon tapes used for artificial delamination in composite. These are the plates look like. So this is the plate, this is glass fiber, this is carbon fiber at the bottom. This is artificial delamination, 6.25%, 25%, different percentage of artificial delamination we create with the help of the Teflon tape. Then the specimen for tensile testing. This is the diamond cutter. We cut it through size. Next, we have done it after plate. We have done. This is the fabrication. We have done it. Then we have manufactured curve panel specimens. This is how it is being manufactured. So the whole composite fabrication unit is 2,000 rupees. It just needs some consumable and a roller like this, hand roller. Initially, I saw it in metallurgy department. Then we in civil department, we have also started 20 years ago. Casting of fiber metal laminate. Fiber metal laminate is this one layer aluminum and fiber, aluminum, fiber, multiple layers can be put into that. This is CNT, carbon nanotube. So these are available in powder form in market. You can add it to our concrete, you can add it to our matrix here in for composite material. So we are working in adding in our composite matrix and testing for vibration. Fabrication of CNT, reinforced composite material. So this is the first multi-wall CNT. We are using multi-wall CNT plus acetone. Then we do stirring. Then sonication being done. Then it is added with epoxy, preheating, then mixing, then stirring. Then again sonication goes to vacuum chamber and hardener is being added. Then molding is done, composite plate, and then tensile test and vibration sample has been prepared. So this right now this test is we are going on. So these are the set of the nano composite stirrer and sonicator and cutter. These are the things. So this is the instrument for instrument machine 1195 for tensile testing. What we do actually, once we do the tensile testing, we got the strength of the material. we got the strength of the material, then it is being in the program, we put it inside the program, and plate natural frequency we predict from the program, and we test it. The frequency, testing of the frequency is also carried out by help of a FFT analyzer. These are the tensile testing. Then this is the vibration testing. Equipments for modal testing. It's called modal testing. So this is the test setup. So this is the vibration test. So in fact, this is the data acquisition system. This is called the impact hammer. It's a normal hammer, but it's called impact hammer because this is connected with the machine, so that if the software says that how much load you are giving, it will be measured. So we'll give the load to the plate specimens through this impact hammer. The plate will vibrate and it will be collected through accelerometer to this machine data acquisition system. This data acquisition system is again connected with the laptop. Here the software is there, and the software is detect from the signal from time domain to frequency domain, so from which we will get the frequency. So this is the display unit. This is the whole setup is called FFT analyzer, used for the vibration test. This is the modal hammer. This is company called Bruel and Kaiser. Then this is the hygrothermal chamber. This is the temperature bath. We put it in multiple temperature, 100 degree, 200 degree, 300 degree, 400 degree. Similarly, humidity 0.5%, 0.25, 0.5, 0.75, 1 degree, 1%. So multiple humidity percentage we have put it, and we try to show what is the effect on its frequency, natural frequency. Then called what is FRF? FRF is the frequency response function. Frequency response function, it is actually when we measure the natural frequency, it shows a frequency response function. So you can see it, how it looks like. These are the steps of the, and this is a FRF. The top one is a FRF, the bottom one is called coherence. Coherence actually, the top one, the peaks, these are the peaks of the first frequency, second frequency, third frequency, fourth frequency. Every structure has multiple frequencies. So these are the first, second, third, fourth frequency, and the coherence, as you can see, the value is more or less close to 1. Value of close to 1 means it is very good reading. Means during the experiment, you can say that it's giving good reading or bad reading. So if coherence is not good, we reject the reading there itself, and do repeat the test. This is a fabrication has been done in the local fabrication shop to test different boundary conditions. So here actually bolting arrangements have been made to keep the plate. So either simply supported or clamped or cantilever, all these things have been arranged. This is a free case or free boundary condition. This is another boundary condition. This is important boundary condition. So free means your program matches more closely to the free boundary condition. When you give free boundary condition, it most matches, because actually every boundary condition, when you do it, actually there remains some error remains, but this is having the least error. Then coming to some of the results, free vibration results. So first actually we'll do the this is the conversion study. Conversion study has been, for every finite element we need to do the conversion study, 4x4, 8x8, 10x10, and then match with the result. So as you can see, 10x10 mesh shows proper conversions. Then comparison with previous studies. So finite element, we compared with finite element results, our study, then our study with the experiment. So we compared, first do conversion study, then we do our result with the previously published result of Crowley, experimental result of Chakravarti. So finite element result of Zhu et al. Multiple authors who have compared our results of the finite element, and then we have yes. Variation of natural frequency with different number of layers. In this is a clamped boundary condition. As you can see, if you increase the number of layers of the composite, the frequency goes on increasing. First frequency, second frequency, third frequency, fourth frequency, and these are, one is finite element based, other one is experiment based. These are, so the two lines based on, you can see how is the matching occurs. Finite element experiment, finite element experiment. So we have done experiment as well as the finite element. Similarly, aspect ratio. Aspect ratio means length by breadth. Length by breadth of the plate is, when it is a square plate, it is 1, or else it is 0.5. Then if you increase length, then the breadth, it is 1.5, 2, it occurs. So this is the first frequency, second frequency, third frequency, fourth frequency. So an experiment and numerical, as you can see, with increase of the aspect ratio, so the frequency increases in this case, but decreases in the first frequency. So this kind of things. So all these things has to be studied for composite to composite. Variation of natural frequency for different boundary condition. So this is, one is the top one is called clamped condition, which shows the highest, then simply supported, then free, then cantilever is the lowest frequency, and fully clamped shows the highest because of restraint at the edges. We have done experiment as well as the computational values. Then effect of temperature. Effect of temperature, the frequency decreases. Frequency decreases. So we have done it. This is in Kelvin, means 300 Kelvin, 325 Kelvin. 300 Kelvin means normal temperature. Then we increased by 25, 50, 75, 100, 125. So as you can see, this happens for the frequency decrease with the increase of temperature. This is for moisture. With increase in moisture concentration from normal moisture to 0.25 increased, 0.5 increase, 0.75, 1% increase, the frequency decrease. This is delamination. With delamination, as you increase the delamination, the frequencies decrease. So whether it is for clamp, or simply supported or cantilever. So this is the first mode, this is the second mode, and every time with increase of delamination, the frequencies decrease. Delamination means it's a defect. So due to the defect, naturally it has to supposed to decrease the stiffness, reduction of the stiffness. The white looks like is the glass fiber. The black look like one is the carbon fiber. This is all done with carbon fiber as well. Carbon fibers are costly. Carbon fibers are real. Our civil engineering applications like roof and wall panels are mostly done with glass fiber, but military aircrafts are done with carbon fibers. So a glass fiber 1 square meter comes around a 1,000 rupees, 1,500 rupees, but carbon fiber comes around 5,000-6,000. So carbon fibers are costly. So we have done less experiment, but we have done it. This is the effect of repeated application of temperature. Repeated application of temperature, as you can see, So the frequency decreases with the increase of temperature. Then we have goes on decreasing, repeatedly giving the decreasing that certain point it does not change. So number of heating and cooling cycles, we have heated and cool, heating and cool, heating and cooling, we have done it, but after certain time it does not decrease. You can see so many readings here, there are sudden decrease, and there are so many readings are here, so many dots are there, so it remains constant. Delaminated composite plate subjected to temperature, delamination and temperature both are there. Initially I have shown you the effect of temperature. This is a delaminated composite plate with temperature. This is a cylindrical cell. Next we comes to the cell, range of cell subjected to strip delamination as just like plates also, but the reduction is significant. If you goes on increasing the temperature, the reduction is significant. This is a spherical cell, less reduction is there. This is elliptic paraboloid cell. Elliptic paraboloid cell, this is the ratio of Rx, Ry and Rv. So this behaves like plate. This is a plate versus a cell. So this is the plate. Then the FEM and experiment. Next, compared with a plate, that is the plate, and this is a cell of different curvature. Here I am showing a curvature Ry is equal to 0.91. In fact, we have done a fabrication for manufacturing of cell specimens. Ry changes. You can see how the frequency increases. And these are all mode shapes of cells. Mode cells, you must be knowing there are multiple modes in a structure. When a structure vibrates, there are multiple modes. So I don't know how much you know about this. So this is 1 1, this is 1 2, this is 2 1, this is 2 2. Means if you might have marked, if you just a rod, you hit it, not rod, it has to be a thin rod. If you hit it, it will go up and down, up and down, up and down. And sometimes one part of it is in top, other part is in bottom, that way. So this is in 1 1, just like deformation shape, but this is 2 1 and this is 1 2 and this is 2 2. So the shape of the plate becomes this kind of, during the vibration, this takes the shape of this kind of shapes. So this is a mode shapes at 300 Kelvin, means normal temperature. We are trying to show what is the change of mode shapes with respect to the increase in temperature. We have seen this is with 400 Kelvin, that is 300 Kelvin, this is 400 Kelvin. So this is the modes of this cell. Then we have done stability problems, static stability and dynamic stability. We have done it. Buckling occurs when buckling must be heard of. Buckling means that pi square EI by L square, buckling load. So Euler's buckling load. Same thing we try to find out for a plate. Same thing, the load we are trying to find out for a composite plate. So here actually nonlinear strains are used for the derivations of the buckling matrix or the geometric stiffness matrix. This happens when member or structure stiffness strain energy in bending equals to the strain energy of the membrane strain energy. Means there is a stiffness, this is called kg, which is called k minus kg is equal to 0. I have shown you sometimes back. Kg is the geometric stiffness matrix and k is the bending stiffness matrix. Bending stiffness matrix. So when k minus lambda kg is equal to 0, when lambda is such that when you put it to eigenvalue routine, eigenvalue must be heard of. These are vibration, buckling, or we could do computationally or even analytically also. You need to do eigenvalue problem. These are all eigenvalue problems. The frequencies can be found out. A minus lambda b is equal to 0. So that's eigenvalue problem. So the vibration and buckling problems are eigenvalue problems. Whether k minus lambda kg or k minus lambda omega square m, these two are called the eigenvalue problem for vibration or buckling. So I am now talking about buckling. So vibration we have talked about. So this is called geometric stress matrix or initial stress matrix or stability coefficient matrix, Kg. So the first one is vibration, second one is buckling. Buckling occurs when we put it to a eigenvalue routine and increase the value of lambda gradually. At a certain point of time, k is equal to kg. When lambda increases 1, 2, 3, 4, we are 1.3, 1.4, gradually put it in a loop. So in a loop, it gives multiple values, and at certain point of time, k is equal to lambda kg. At that point, actually, lambda value is equal to the buckling load. Lambda value is equal to the buckling load. That way we do it. So this is the kg matrix. Depend upon the nonlinear, the non-in-plane stresses, depending upon the in-plane stresses. When there is only nx, no ny, no nxy, it becomes a beam like column buckling. So similarly, we same concept we put it to composite, and we have done experiment as well as the computational. This is the machine we have used for doing the buckling tests. We put it the specimen here. We put it the specimen here. Increase the load. At a certain point, it buckles. So buckling, you might have heard of. If there is a small specimen, it will get crushed. If it is a flat specimen, it will get buckled. It will take the shape of a geometrical sine theta or cos theta. The shape will buckle. So that way it is called buckling. And plate before buckling. Oh, here is the buckling. Plate before, after buckling. This is the buckling occurs. We have done it for a few specimens. Then this is a fatigue testing machine. This, in fact, this machine is a unique machine in our laboratory, which can do tensile testing, compression testing, and fatigue testing machine. All 3-4 types of all testing can be done with this. Previously, we are doing because this machine was not there. So when this machine comes, we are doing everything with this. So this can do bending. This can do buckling, bending, buckling, and fatigue. This is how the fatigue failure even occur, critical buckling load. Then we load deformation curve, we plot it. Then the displacement load versus the displacement has been plotted, which is the load, which is the initial part of the curve deviated linearly, is taken as the critical buckling load as per the paper of PK and Simon 2006. Similarly, convergence study has been carried out for buckling, comparison of buckling load compared with some experimental result. Then we have done experimental and numerical studies on buckling. As we increase the fiber orientation angle, the buckling load decreases. As we increase the aspect ratio, the buckling load decreases. So both FEM and experimental results show similar kind of trend. Buckling loads laminated composite plates under clamp-free and simply supported boundary conditions are much lower under clamped boundary condition. Clamped boundary condition shows higher frequency, higher buckling load because of the restraint at the edges, higher stiffness. So naturally, if it's clamped means there is no everything has been restrained. all the displacements u, v, w, theta x, theta y are restrained, so it higher frequency as well as higher buckling load. So the buckling load can also be found out using dynamic approach. This is one of the dynamic approach, unique approach. Wherever you cannot use static approach, we use the dynamic approach to get the buckling load also. So means you any plate. Sometimes actually what happens when you do a eigenvalue routine, so sometimes actually it does not yield any result. So there actually we adopt dynamic approach. It can be done computationally or it can be done also experimentally. Experimentally we have tried, also computationally we have done. Means it's a vibration problem, increasing the load. So at certain point, this is the natural frequency. As we give on loads, the frequency decreases, and if you go on touching, extending to the x-axis, wherever it touches, that is the buckling load. So that is the experimental buckling study by dynamic approach. Experimental buckling load can be found out directly by the machine I have shown you, and this is also by doing the vibration test. We can also get the buckling load. Doing vibration test for the 5 specimen, we can also get the buckling loads. Then we have tried dynamic stability analysis, means harmonic loading. So it's called through a bulletins approach has been conducted, and there is a static load factor and dynamic load factor. It contains both static load and dynamic load, both static load and dynamic load. So this is the type of curves we encounter. So this is the increase of dynamic loads. This is the excitation frequency. So with increase of number of layers, the structure, the plate becomes more stiff and become unstable after this much frequency, which was number of layers less, is becomes unstable earlier, because this is excitation frequency higher, so this becomes later. Similarly, square plate and different rectangular plates, dynamic stability. Dynamic stability means this is the zone of instability. Whatever you are seeing is zone of instability. Rest portions are stable. This is the zones of instability. So if you are doing this plate, you forget about this zone. Other zones, there will be resonance in this zone. There will be other zones are stable. Other zones are stable. Other zones are stable. This is clamped. Clamped means these are the clamped one, which is the highest excitation frequency. This is the orientation. And again, layer wise. This is the fatigue testing. Fatigue testing, a lot of things can be done, but I am showing only one. So one student has worked in fatigue testing of composite with nano alumina. This is a plate with composite with nano alumina. So this is not nano alumina. This we have done it with normal composite SN curve for 8-layer symmetric glass laminated flat panel with 350-degree temperature. This is for temperature only. So we have studied also this one, and also done the SN curve for with nano alumina as well. This gives you fatigue, means how much repeated loads it can take off. One-time load and repeated loads behavior is different. So we have done also right now. We are doing also fatigue testing. We have done also fatigue testing with CNT carbon nanotube plates, nano alumina plates. We have done also experiment with stiffeners. Stiffener also we have done the experiment. So in fact, some of the faculty from Bulla, he has done here all the tests, and of stiffener, composite plate with stiffener. Then the present work, finite element formulation is used to free vibration, buckling, and dynamic stability of industry-driven woven fiber laminated composite plates and cell panels. The results using present FEM shows in general is a good one, matching with existing literature. From the above studies, it can be concluded that vibration behavior of laminated plates is greatly influenced by the geometry, material, ply layoff, temperature, moisture, delamination, ply orientation, and type of materials. It is observed that the first and fourth mode shapes are not much affected by the increase of temperature. However, for second and third modes, the convexity and concavity changes are observed due to the depending as the mode shapes shows this conclusion. So the designer has to be cautious while dealing with structures subjected to dynamic loading. This is and composite had the greatest advantage of tailoring. Means actually you know that this is subjected to tensile load, you will do one orientation. This is subjected to compression, you do one orientation, or it is subjected to something. So torque. So what kind of orientation will be feasible? All orientations are feasible. Whatever is showing higher strength, that is done. That's called tailoring. The vibration results can be used as design aids for the dynamic design of composite structures. The model test results can be used as a tool for structural health monitoring of structures, including the location of damage in composites. We have done also composites with cutout, composites of different sizes of cutouts also we have done it. References. My presentation is complete. Now you can ask doubts, if any. Anybody having any doubt? Anyone? Is it connected? Is somebody there?
Unmute karo.
Yes, sir. Yes.
Unmute everybody. So anybody who likes to ask anything?
Post stop করতেছি।
Are they unmuted?
Hello. So if anybody has any doubt, they can ask to our expert sir. Any participants related to this topic, if you have any doubts, so sir is asking, if you have any doubts, you can ask to sir.
पंकज सर, हेलो
Hello.
पंकज सर, विपिन मोहंती।
हाँ, Bipin sir, if you have any question regarding this topic, so you can.
हाँ, I am interested to ask some questions.
Sure.
Sir, good evening.
Good evening. Good evening.
Sir, so many doubts. It's a nice
You
topic.
ask. Time is
Sir,
there. You ask.
Sir, I want this particularly subject matter. I want to again go through that after getting so many, because after attending your lecture, I am getting so many doubts. So, because it is a new topic with respect to my observation.
Ask one or two today. Then you can take my email and ask later or my contact.
Sir, thank you,
Ask
sir. Thank you,
ask
sir.
few.
Sir, so many doubts from the beginning to end. So many doubts. So, let me read again the slides. So, if it is available to me, you can, if you help me, then I can avail your slides. Then, after going through that, through email, I will ask you the doubts.
Okay. ठीक है.
Thank you, sir.
Sir, good evening, sir. Dr. Dattatreya this side, sir.
Yes.
Sir, actually, I'm working on FRP composites for strengthening of under-reinforced masonry. So, if I go for FRP composite for strengthening, sir, I'm using Abacus for the modeling part. So, can you please explain what should I define the interaction properties for modeling the FRP composite and bonding between the FRP composite with masonry?
Like
Could you please explain, sir?
we have worked on concrete as I have shown. We
Yes,
have
yes, sir.
concrete beams we have done. Masonry, you have to cast multiple masonry and how to test it. You need to have a testing facility of the masonry.
Yes, sir.
Testing facility of masonry with multiple schemes of FRP positioning, multiple schemes of like we have tried multiple schemes of FRP strengthening. You have to
Yes.
need to try multiple schemes of FRP strengthening and modeling. You are planning to have purely computational or experimental as well?
Sir, both experimental and computational. Sir, I have the doubt in bonding part. There is a bonding between FRP laminates and also the bonding and the masonry part. How can I simulate that one, sir? Can you please explain that? If I go for testing part also, how can I test for the bonding strength?
No, you need to. You need first actually instead of testing bonding strength, you better actually test some compressive strength.
Yes, sir.
Compressive strength you test it. So whatever test facility you have, accordingly you need to move.
Sir, actually, I have performed diagonal compression test and 4-point bend test on the masonry panel, using FRP laminates. But that the bonding between, if I want to know the bonding, the tensile strength of bonding, or the how the bonding behaves if FRP changes. So how can I do that, sir? Can you please enlighten us that on that area, sir?
Bonding takes care, so should takes care of like you do whatever the strength test you are doing.
Yes, sir.
So bonding is there, then only you are getting a as a whole one is a one structure, na?
Yes, yes, sir.
So instead of testing bonding exclusively, you are testing whole structure as a whole.
Yes, sir.
So bonding is included to that. Now you don't have to worry for the bonding. When you are doing different schemes of um, placing your FRP in the masonry,
Yes, sir.
either vertically in this direction, horizontally in this direction, only at the bottom, only at the top, or horizontal, vertical, only different schemes, and you should do whatever test you are trying to do, you should do. And the same thing when you do modeling, is Abacus having some models similar to this?
No, sir, actually for bonding, simulating the bonding property, the Abacus do not have any that tab. Generally, I have gone through the literature. They're doing as a interaction property that's embedded.
Then you can just modeling Abacus, if it does not have FRP modeling, then you cannot do that, na. So you need to check that one. If Abacus modeling, experimentally, you can say that you can try multiple types of FRP combinations and putting different locations and test it. whatever you are testing, strength test you do, rather than the bonding test.
Okay, sir. Thank you.
Bonding
Thank you.
will
very
take
much.
care, epoxy will take care of the bonding. Bonding will be naturally, if you like masonry, we need more epoxy, but in a composite material, glass, fiber, those kind of things, little less epoxy. But bonding, you don't have to worry, I think. Only you take care of what of the strength test you can do. Modeling, that is, abacus is having that module or not. Whatever abacus is having module, if there is a tutorial, then only you can do that. Or in the YouTube, something you look for, if it is a module is there, then only you can model with the abacus. If there is no modeling like both FRP modeling might be there, but up to which extent it is there, every software has a limitation. Up to which extent it is there, which it serves your purpose or not, that I cannot say. You have need to check. YouTube, you look to YouTube, look for whatever you are asking, like abacus modeling of masonry strengthening. If you get some material related to abacus modeling, then it may help you. If it abacus does not have, then how do you, how
No,
can
sir. Actually, I'm asking that there is no module in the abacus. But
uh,
how can I simulate that one, sir? Can you please
no, you
enlighten about that?
cannot do. I don't think you can do. If it does not have,
Sir,
everybody has a,
any other software, sir? Can you please explain any other software?
I have to check. Somebody, one student was working with a masonry. I have to check with him.
Sir,
We have
I
worked, we have
sir, I will
worked on concrete, because concrete has analytical expressions available. Concrete has finite element modeling, or some or people concrete beam analytical expressions available. I know equations available, but masonry I have to check. I have to check whether what are the status.
sir, I will send you, sir, through your email. I will send you my
My
research
email
plan.
is
Can
there
you
on
please
the
go to it?
website. My
Yes,
email
sir.
is there on the website. You can send a mail. I will
Yes,
ask
sir.
that student who is working on masonry and pass on to you if I
Yes,
got
yes,
it.
sir. Sir, thank you. Thank you very much, sir.
Okay. Anybody else having any question? Or when I reached Kharagpur in 1996, there actually I met somebody to for my PhD professor. Then he told to work in composite. Mukul, composite, we don't have any idea of composite. So he told it's just like, yeah, he is from aerospace. So he told I was working in ISRO. I am a civil engineer. I was working in ISRO and I have joined here as a professor in aerospace. I am working in composite. So in the ISRO, he was working in composite, and uh, he is continuing his work in composite. So, okay, how is it similar to that? No, how it now your building is similar. Your building is under wind load is similar to your aircraft going through the wind, going through the atmosphere. So it's similar. So the forces are similar. So nothing to worry. The modeling is same. Then we started working and taken some coursework in composite and done. No issue. Anyway, so that's the zoning. We have done it last 25 years. Our main contribution is we have done the experimental, most of the things we experiment part, whatever I could not do in Kharagpur, that time same last 20 years, 25 years, I'm doing experiment here. Whatever I'm doing on a MATLAB program, handling with a MATLAB program, there actually we have handled for Fortran programs. Then we have come over here, used MATLAB programs and go on changing everything. So from a normal composite to hydrothermal loading to delamination to everything now, separate cells to everything we have done it. So that way program part and the experiment, everything we have done it. I saw that metallurgy people are doing only bending test. showing various aspects of it. So we have done the dynamics of all these plates.
Good evening, sir.
Good evening.
Sir, I have one doubt related to shear wall. How we can improve the shear strength capacity of shear wall using fiber and force concrete, and which fiber will suit the best for this?
Fiber, if you ask whichever is best, it's carbon fiber is the best, but cheaper is the glass fiber.
Okay.
Glass fiber, putting glass fiber, it improves the shear strength. Say load capacity, it increases, and it comes in unidirectional, it comes in bidirectional. So you can just put epoxy and this glass fiber. If you require more costly carbon fiber, as I have told you, carbon fiber repairs also. In fact, some years ago, somebody has suggested carbon repairing to Puri Jagannath temple, but coincidentally, that has not happened. Still repairs, still these are carried out with conventional steel, but all these things are possible. Glass is convenient, much cheaper, but if you want more strength, carbon is the best. Carbon and epoxy.
Yeah, good evening, Prof.
Good evening.
Yeah, this is Harmansh. I am from VVIT Pune, Bihar. I am
Please.
working as an assistant professor, and I worked in polymers in my master's research. So I just want to know, like, in your FRC, do you are employing any compatibilizing agent?
Which agent?
In your FRC, have you applied any compatibilizing agent to make the bonding more, beneficial and to increase the compressive power?
So something the materials are. No, I
Like,
don't
I
think.
mean, do you require any compatibilizing agent
No,
to
that
make
is
the
if you
fiber
apply
and
it, that is extra. That is not essential. Extra.
okay. Depends
That you
upon
can
the
apply, but
material.
that is the extra.
Depends upon the material employed.
Yes, yes. That's your planning. So if you
Okay.
want to, like we do not like normal concrete, we do. So if you add silica plume, like you in the matrix, we have added nano silica on
Okay.
nano alumina we have added, which has increased its strength. Now we have added carbon nanotube. You can add a carbon nanotube to increase its strength. And there is a
Because
material you might have heard of, graphene. Graphene, if you
yeah,
add it, it also adds your strength. These are the
because these
materials
days,
which can be added to the matrix for increased strength.
yeah, because these days, like metal organic frameworks are also getting employed, and
Naturally,
some biochar
conventional
also.
conventional composite has been done. You need to do something else.
Okay. And for the automotive industry, I think plant fibers are like beneficial, or we have to move for the carbon fiber material also.
Then carbon and glass fiber. Plant fibers are taking small loads.
Okay.
These are good, but the load capacity is small.
Okay.
So we
Okay.
need
Thank
to
you
go
so much,
for
Prof.
these synthetic
Sir,
fibers.
sir, sorry to interpret. We have another session which will start
Sure.
right at 8,
Sure,
8,
sure.
8 p.m.
Okay.
So,
So
sir,
anybody
with your
interested can communicate later. So everything close by me. You can start.
sir, with your kind permission, can we stop this
Sure.
session, sir?
Sure. I am quitting. Okay.
Another session we have at 8 p.m.
Okay. I am quitting. Thank you very much. Okay. So can I quit?
Sir,
Can I
sir,
quit?
sir, sir. Lastly, uh, I must thank to Professor Dr. Sisir Kumar Sahu sir for giving the valuable talk on recent advances in FRP composites for structural applications, and also we are interested to listen from Dr. Sahu sir. Another session is there, that is on 15th November. So thank you, sir, for giving us the valuable time for this ATAL online FDP program. Thank you again, sir.
Thank you very much. Thank you very much. I am quitting. Okay.
प्लेट रेडी करो, टेबल रेडी करो, केक कटा रेडी करो, कभी नेले हमें थोड़ी देर काट दो बस। So them, so sir is very soon will join with us. So please, all the participants are requested to stay. So our next session, Prasad, Lakshmi Bara Prasad M. So I want to introduce our speaker. First of all, good evening, sir.
Sir, good evening, sir. Yes, sir. Sir, is it audible, sir?
Yes, sir.
Okay, good evening.
Yes, sir. Audible, sir.
Yes, sir.
I want to introduce our speaker, guest, Professor Dr. Lakshmi Bara Prasad M. is Associate Professor of Civil Engineering Department, National Institute of Technology, Silchar. About his qualification, he has got his PhD in Civil Engineering from National Institute of Technology, Warangal in 2012 and did his MTech in Structural and Construction Engineering from Kakatiya University, Warangal in 2004 and BTech Civil Engineering from Sri Venkateswar University, Tirupati in 1999. His area of research is performance of structural elements under static and dynamic loading, new materials in concrete waste management, in construing quality control and quality assurance of construction, artificial intelligence in construction management, new construction methods and equipments. He has 18 years of experience in teaching, research and also industry. The projects that is external funded, the title of the projects are Fund for Improvement of S&T Infrastructure to strengthen the research facilities in the department, funding agencies, Department of Science and Technology, India 2022 to 27, which is ongoing. Another project title, Development of Geopolymer Aggregates from us, that is dry and pond, for applications in biobricks, low-grade pavements and precast elements, and the funding agency is DVC-R and D, Manthan Government of India, which is again ongoing. Development of geopolymer aggregates, pellets as a replacement of aggregate for construction industry. The budget is around 12.5 lakhs, which is a MSME project. SAR has research publications in the international journals 32, international conferences 35, patent granted 4 numbers, national journals 10, national conferences 15, book chapter published 12. The courses taught at UG and PG, also at PhD level, the construction management, contracts and specification, quality control and quality assurance, strength of materials, engineering graphics, structural design, that is RCC, concrete technology and structural analysis. Sir has guided and supervised many students, already completed PhD 4 numbers, MTech 38 numbers, and BTech 25 numbers. Ongoing PhD 5 candidates, MTech 2 candidates, and BTech 1 candidate. The projects handled as AEE, Associate Dean, and P&D, tendering to agreement of medium irrigation project under JICA program, vertical extension of GH3, execution and new GH4, hostel tendering and award, future research plan, cost-effective eco-friendly cementitious materials for construction scale, 3D printing, artificial intelligence techniques in construction management for the reduced risk and enhanced performance of project work. Sir has different administrative positions. Sir is faculty advisor for karate and skating, year 2017-18 and 2018-19, faculty advisor for Eco Club, member of examination branch from Civil Engineering Department, NIT Silchar, faculty advisor for Photography Club, Boys Hostel 6 Warden, NIT Silchar, associate dean P&D, NIT Silchar, FIC Operation and Maintenance of Central Library, associate dean, NIT Silchar, from 2024 to till date. He has handled different departmental positions: TechCube coordinator, member of departmental postgraduate progress committee, secretary of departmental undergraduate progress committee in NIT Silchar, faculty coordinator, and member and secretary of department of PhD monitoring committee. Membership: member of Indian Concrete Institute, and executive member secretary of ICI Guwahati Center, member of Institute of Engineers India, and member of Indian Society for Technical Education. So with this biodata, so definitely sir, we are happy to see your CV, and I welcome you again to this online ATAL FDP program sponsored by AICT.
Yes.
And thank you sir for sparing your valuable time to the Department of Civil Engineering, Synergy Institute of Technology, Bhubaneswar. So I again welcome you sir to start your session. Thank you sir.
Thank you. Thank you very much, sir, for a detailed CV. Dr. Pankaj Kumar Das, sir, coordinator of this program. Thank you very much. Sir, I am sharing. Is it?
Yes, sir. It is visible.
It is visible, na? I am going
Yes,
to
sir.
presentation mode. So now it is in
Sir.
presentation mode, sir.
Yes, sir. Yes, sir.
It is in the presentation mode only, na? Okay. It is in full screen, sir. Yes.
Yes, sir. It is full screen.
Okay. Thank you. Thank you, Pankaj sir, for giving me
Thank
this
you, sir.
opportunity to share my views and ideas related to the advanced materials in civil engineering. And I am very much thankful to the patron of this program, Sri Binod Das, and other faculty members, those who are continuously engaging with the faculties and conducting this program. So this is a revolutionized construction with suitable advanced materials. This is the FDP. Under this, today my topic is sustainable infrastructure solutions and advanced materials for civil engineering. This is our topic today. So here I am going to cover all the topics related to the what are the important advancements in the materials of civil engineering and why we have to think in the direction of sustainable infrastructure solutions. So that things we will discuss here. So before going to the topic, just I want to share about my institute. I am working as a associate professor in NIT Silchar from last 12 years, and before that I was assistant executive engineer in public works department. So this is the 31 one of the 31 NITs, and we are in top 10. And here we have BTech program. Along with that, we have 5 specializations in master's degree, like structural dynamics and earthquake engineering, geotechnical and water resource, and transportation engineering. So it is established long back in 1967, and uh, we are the one of the 31 entities. So here, if you come to the contents, we are going to mainly discuss what is the timeline history of the concrete, how it is developed, then developments in concrete making methods, why we have to think about the sustainable infrastructure solutions, then what are the different advanced materials for civil engineering, then what is the additional benefits or additional innovative construction techniques we are going to see nowadays, and relevant publications we are going to see. So first of all, whenever we are going to use that word sustainable infrastructure solution, so what is sustainable, what is sustainability, and why we have to think in that direction, and these things we have to know basically. See, infrastructure is the, just 1 minute. Infrastructure is the main, civil engineering means infrastructure. So in the infrastructure, actually nowadays we have to think in the direction of sustainability. So first of all, why we have to think in the direction of sustainability, I will say, see, sustainable infrastructure development means whatever the innovatives we are doing nowadays, that should be environmental friendly, and at the same time, whatever the improvement or whatever the development we are going to do, that should have a minimum or environmental impact. Let us say, suppose I introduced some cement or I introduced some product as a civil engineer, it should have a very least effect on the environment, and there should not be any problem with the, for the environmental side. Best example I will say, suppose now today we are getting the air at free of cost. But if you say water, we are not getting at free of cost. Even if you are in a small village or you are in a big town, anywhere, you have to purchase the water. The reason is earlier we are getting the free of cost, but we are, because we are not able to maintain then sustainability. Sustainability means simply I can say whatever the facilities we are enjoying now, that we have to give our to our future generation without any compromise in any of them. So now we are getting oxygen at free of cost. After 20 years also, you have to give the same confidence to your grandchildren, to grandchildren, that you will get the air at free of cost. Then we will say it is a sustainable development, and you are thinking in the direction of sustainable infrastructure development. Because not only the civil engineer, all the engineers are the responsible for the infrastructure development, and that's why with the infrastructure development only you can see the social equity. That means ensure infrastructure benefits to all the members of the society. Should not be particularly for one type of people or one type of this, like it should not be like that. It should be the benefit should reach to all the people, and it should be economic viable also, because in long term sustainability plays a vital role actually. So when you comes to the, for the development of sustainable development, what type of advanced materials we have to use? So suppose if you take, we when it started with the infrastructure development in earlier days, whatever they have used is, they used the only locally available material. But now what is happening is, in the name of infrastructure development, we are using so many new materials which are having the effect on the environment. Let us say, so you use the advanced materials for civil engineering, at the same time you think about the sustainability also. They should be whatever the material you are using for the infrastructure development, it should be it should not have any effect on the environment, or it should not create a problem to the environment. Like that, like fiber reinforced concretes you are going to develop. So you develop the concrete, but at the same time, it should be sustainable. Means it should not have any effect. So for this reason, actually, mainly what we have to do is we have to use the environmental friendly materials. Whatever the, suppose let us say we are using the cement, but when you take the cement itself, when you hello, yeah, my voice is coming now, sir.
Yes, sir.
Yes, sir.
Okay, okay, right, thank you. So, so we have to think about the cement. Almost when I am going to try to produce 1 ton of cement, automatically, unknowingly, I am producing the CO2. So it should not be like that. So that's why now we have to think, uh, even though we are developing the infrastructure, but we have to think in the direction of the replacement to the cement by using pozzolanic materials, which are in the name of industrial byproducts, like you can name fly ash, GGBS, metacoilin, silica fume, rice as gas. All these are the byproducts. So if you replace the cement with them with some percentage, so you are reducing the utilization of cement. Not only reducing, nowadays we are completely zero cement concept also came. That also we will discuss. So like that, we have to go for the advanced materials which are sustainably which are helping for the sustainable development, and smart materials. Even nowadays, instead of working hard, you have to work smarter, because even when you are deciding your thesis also, when you are because if you are doing a research scholar, or if you are doing some research, nowadays what you have to do is you have to do the smarter work, not the harder work. Example I can say, suppose you want to develop a some mixed design for self compacting concrete. So definitely, if you want to do a mixed design for the self compacting concrete, what you have to do, you have to go for different trials, you have to go for different combinations of the powder, fine aggregate, coarse aggregate, then water or some admixture like that. So all these things, if you do experimentally, and if you do after experimentally, we will get one trial mix. Then after that, we will go for number of trials to achieve the final mix proportion. Instead of that, what I am saying is smarter means you utilize whatever the existing data is available with you. From that, you generate a database in such a way that it will be going to give you all the existing details. Suppose if I am using this, I am replaced the cement with fly ash, and I am replaced the fine aggregate with this quarry rock dust, or I am replaced the coarse aggregate with the recycled aggregate, or I am using some type of chemical admixture. Then what will be the promotions? What is the input? What is the output? Like that, you prepare a table, and from this, you take the help of artificial intelligence. Nowadays, we have this ANN is there, ANFIS is there, machine learning is there. So by taking their help, what you do is you train them with the 70% of the data, and you test it with the 30% of data available with you. Then from that, a trial mix easily you can get. Then with that, if you start then you can economize the so many things you can so even budget is also going to be very less. Otherwise, only if you are doing experimentally without doing all this exercise, then it will take so much of cost. So that is called hard working. Instead of hard working, we have to work smarter working. So you decide the trial mix by providing some mixed design procedure, by adopting the latest technologies like uh, Internet of Things or artificial intelligence or some any soft computing skill. It may be artificial intelligence, it may be anything. You have to use the soft computing so that it will help you in arriving that mix proportions, a trial mix. Then from the trial mix, just with the 2 3 trials only you can achieve. So that's why you have to go for advanced materials, advanced concretes, and by utilizing this chemical admixtures and all that, but at the same time, we have to work smarter. So when you come to the timeline of concrete and cement history, so Romans were the first invented this cement-based concretes. So before that, if you take Egyptian pyramids are there and all there, actually they are going to use the lime mortar. If you see this Roman concrete construction, earlier mortar means it is lime mortar, not cement mortar, because 1800 century in at that time you are not having any concrete mortar. Mortar means it is lime mortar. So they are going to grind the lime along with the fine aggregate, and from that in the field only they are going to prepare it, and that they are going to use. And in that lime mortar they are going to use some all whatever they have used in locally available materials only, and which are not harmful to the environment, like that. Even they have used the paint also, if you see, that is not enamelic paint or some other, because these paints are very dangerous nowadays. Suppose if you see during the Ganesh Chaturthi and all that, we are preparing a nice idol of Ganesh with utilizing so many chemical paints. So these are harmful actually. Instead of that, you use the natural colors, you use the earth, that is environmental friendly, that is called sustainability. Because if the idol is prepared with the earth and that is going to be dissolving in the water, so no environmental problem. Like that you have to think. Even when you are thinking for a product also, we have to keep in mind that it should be environmental friendly. So already I told you, when it is started, we started with the lime mortar. Just we will discuss about the history of this. We started with the lime mortar. Then after the lime mortar, problem with the lime mortar is readily you cannot keep it. You have to make it in the site, and at ground only you are preparing the material. Then you are utilizing that. So because of that, it will take so much of time and so much of delay. You even if you want to construct one building for residential purpose also, minimum it is going to take 1 year to 1.5 years. So because of that, then we have shifted to the concrete, that is cement based concrete, which is prepared from the hard rocks of cement is uh, prepared from this utilizing the that is also from the natural resource only. But the problem with the preparation of the cement is, when you are preparing the cement, indirectly you are producing the carbon dioxide. Almost 6 to 8% of carbon dioxide in the world is because of this cement production. So at that time we want the alternative. So initially we are happy cement is giving good strength, and we developed the concrete. And when we have developed the cement based concrete, obviously it is a vibrated concrete, normal vibrated concrete, because with proper compaction only you are able to remove all the voids, either it may be air voids or it may be water voids. So like that we have developed the normal vibrated concrete. Then with that we started constructing G+1, G+2, like that. But when the industrialization is happening, when the industries are coming, when the population is increased, we are not satisfied with the regular concrete. Then we have a thought about the high strength concrete. So high strength concrete and high performance concretes, these are all for high rise buildings actually. First we will discuss about high strength concrete, then we will go for the high performance concrete. Let us say you are going to construct a G+3, G+5, then no problem. You can use M20 or M30 like that. But when I am preparing a G+50 or G+60 building, this is a G+80 building in Chicago. So you cannot use your regular concrete. Obviously, you have to go for high strength concrete. When this, because the advantage of high strength is with the slender cross section. That means with a small amount of the concrete only, you will achieve the higher target strength. That is the main advantage of the high strength concrete. So because of that, we developed the high strength concrete by using these different methods, and we succeeded in developing. Obviously, we have taken some lesser water cement ratios, and we have introduced some pozzolanic materials in the concrete. And by the way, we are able to achieve the high strength of the concrete. But problem with the high strength concrete, earlier problem with the normal vibrated concrete is the cross sections are going to be very high. So to reduce that, we came to the high strength concrete. The cross section is reduced, but the problem is when you are going to test the stress strain curve of the high strength concrete and all that, after failure, after reaching its ultimate strain of concrete, you are going to see a sudden failure. So this is not going to be accepted actually. So sudden failure of concrete is always dangerous. So even though it is giving the high strength, it is taking up to 60 MPa, 70 MPa. But when failure comes, you are going to see a sudden failure. So that's why we have to come out from that. Then we have a thought about not only high strength, we need the high performance also. High performance means along with the strength, even after it should give a long life and it should not have any sudden failure. So because of that, what they have done is only increasing the cement content is not the criteria. So for that, they have given a limitation on the dosage of the cement. For you should not cross 450 kgs per meter cube of concrete for developing the high performance concrete. And similarly, water binder ratios, it should be in the controlled manner, and you have to use some pozzolanic materials which are industrial waste, but in other way they are going to give the full strength as a high performance concrete. So in that way, this high strength, high performance concrete is the solution to the problems what we have earlier. But the thing is, for developing the high performance concrete, actually you need the technically sound persons, because whenever you are going to select the material, whenever going to design the mixed proportions, a trained person only able to develop the high performance concrete. And whatever the materials you are suggesting, whatever the chemicals you are suggesting, all these things along with the vibration, then with the perfection of performance, then it is going to be very costly. So actually what happens is, even though whatever the materials you have used in all this process, from normal vibrated concrete to high strength concrete, high strength to high performance, the strength is achieved only with respect to compaction. Without compacting, you are not able to get the strength. So that is the drawback of this. Then still again we are thinking in overcoming that. So that also we will discuss here. So again, in developing all these concretes, what we have done is we have used the concept called
Sir, sorry to interrupt. Sir,
yeah,
we can only see that fast slide. I think the PPT is not in presentation mode.
it is not in the presentation mode. One
Yes,
minute.
sir.
Oh, I am in the presentation mode actually. So what it is presenting? Oh, still it is here only.
Yes, sir.
Oh. So, but I am going in the now it is in the presentation mode.
Sir, we can only see that fast slide only.
First slide only. Now,
Yes, sir.
Yes, sir.
Yes, sir.
okay, then 1 minute I will do. Just once again I will share. Just wait. Okay. Oh. Now it is changed. Is it visible? Other slides?
Yes, yes, sir. Yes, sir.
Now it is changing the slides.
Yes, sir. Yes, sir.
So just once again, I am showing, sorry. So this is about our NIT Silchar, and these are the contents what I have discussed. And this is the sustainable infrastructure solution actually. Whatever, if you are developing any structural infrastructure development, means you have to think in the with respect to sustainability only. Then advanced materials, always whatever the advanced materials you will go, they should be they should not create any problem on the environment. And already I told you how to think in the smarter direction. And this is about the uh, timeline of concrete and cement. So it is started year back in Romans, then Egyptians, then lime mortar, then cement mortar, then cement concrete, like that. But only one thing with the concrete is you will achieve the target strength only with respect to compaction. Compaction and curing. These two things are very much required because it should be compacted thoroughly and it should be cured thoroughly, then only you are getting. And that too, whenever I am saying this concrete, it should have some workability because it should occupy all the spaces in the infrastructure. So that's why a concrete means it should have the workability, it should have the compactability, it should be cured properly, so that because in all cement based concretes the with the respect to hydration process only you are going to get the strength. So that's why we have to think with whatever the concretes you are developing, it should have the workability, it should be compacted properly, and it should be cured properly. So many things are involved. So it is going to be costlier. And again, I am going to say high strength concrete and high performance concrete. Slides are changing, na?
Yes, sir. It's changing.
Yes, sir. Right. Thank you. So, in all this process, when you are preparing the special concretes, you should keep in mind that not only you are going to think about the special concretes and all that, it should be environmental friendly. And environmental friendly, and at the same time, if it is locally available, then somewhat it is good because it should be economical also. I propose so many environmental friendly, but which are not available locally, then it is not a good solution. You give a environmental friendly solution, but at the same time you try to utilize your locally available materials like ashes. Suppose if you take fly ash, in India plenty of fly ash is there. Suppose you are not having fly ash, then other slags are there, metacoilin is there, silica film is there. You use that, you replace, because what we found is when you are replacing this, because these are one in two ways you are going to get the solution. One is you are giving a solution to the waste because it is a byproduct from industry. And another way, you are improving the strength properties by using environmentally friendly and locally available. That is the main concept. So already we discussed regular normal vibrated concrete. So we have not satisfied because if I want to construct a G plus 50 building, actually you are going to get a cross section of 2 meter by 2 meter or 1 meter by 1 meter, like that. So instead of that, what we have to do is we have to go for high strength concrete. So in case of high strength concrete, obviously you are going to for the slender columns and slender sizes. So the cross section is going to be very small. So by that you are going to develop. The thing is you are able to achieve the high strength, but it is not going to give you durable. When you are testing this and when you are going to see during the earthquakes or during the failure time, the structure is going to have a sudden failure. Sudden failures are not at all recommended in our infrastructure, because if it is a sudden failure, then the loss to the human being or loss to the infrastructure is going to be very high. So we don't want any sudden failure. We want sufficient ductility in the concrete, and like that only we will develop. So for that, we developed the high performance. But high performance concrete problem with the high performance is, even though it is high performance, it is durable, but it is going to be very costly because after you have to use all these special materials. Along with that, you should have a technical person who is able to handle this concrete, and you have to compact it thoroughly, you have to cure it thoroughly. So many things are there. So because of that, we have not we it is going to be a costlier. It is not available for all. Then in Okamura in 1986 has developed the self-compacting concrete. It is a concrete which is going to compact under its own weight, but it should satisfy three conditions like passing ability, flowability, and segregation resistance. So passing ability means flowability. First, we will see flowable. Flowable means if I am pouring it on a surface, it should flow like a water. It should flow like a liquid. Then no need of any compaction and all that. And another thing is it should pass this whatever this reinforcement is there now. Obviously, when I am using it in high strength concrete and high performance concrete, you are going to have a congested reinforcement. So because of the congested reinforcement, even it is not possible to compact. So in that cases, it is going to be very helpful. No need to compact. Just it will pass all the obstacles. So that's why we need this passing ability. And segregation resistance means because whenever you are developing this self-compacting concrete, actually what happens is we have to use the batching plant and it should be developed in the factory only. It should not be developed in the at the site because these we are going to develop at the large quantity. If it is small quantity, getting that self compaction is not that much easy. So that's why it is mixed in a ready mixed mixer or in a batching plant. Then only it is transferred to the ready mixer. Obviously, when you are transferring the self compacting from concrete from the manufactured batching plant to the site, minimum it will take half an hour or 30 minutes or 45 minutes. So in this transportation process, it should not stick on to the walls of that ready mixer. So that's why we will see the segregation resistance also. So if it is satisfying all these, then we call it as a self-compacting concrete. So the advantage, sometimes it may be called as self-consolidated concrete. Compaction or consolidation for concrete both are same. If it comes to the soil, the two are different. Because for a concrete, removing the air voids or removing the water voids is within the sufficient time only we can remove. So that's why whether it is a self-consolidation or compaction, both terms are same for concrete. And so here, no need of any external vibration because what happens is in the sides it is not possible to compact and sometimes there is no chance to compact. So in that cases we will go for this and self-curing concrete. After that, see, already we have seen whenever you are going to say two major criteria are it should be compacted thoroughly, it should be cured thoroughly. So this is going to create the problem. So that's why what we can say is instead of going for the compaction, now not only compaction, we can go for curing also. So even no need to cure the concrete. So that is called the self-curing concrete. There are two types. Internal curing agents are there. External curing agents are there. So that if you add these in the concrete along with the self-compaction, no need of curing also. Nowadays, these are also came into practicality and recently some of the L&T works I have visited, they are using this self-curing agents because in some places actually curing is not that much of easy work. Even you will not get the drinking water and in that places if you want to go for proper curing it is not possible. So that's why we will use this self-curing agents like lightweight are there, super absorbent polymers are there, shrinkage reducing admixtures are there, lightweight aggregates are there, wood powder is there. Like that, they are in the different form. Generally, liquid paraffin, it is high and low, both are there. Based on your requirement, we will use sometimes a light one, or in sometimes we will use the heavy one. Okay. Then sub-absorbent polymers also there that can be used as the internal curing agents. So basically, with the advantage of self-curing is already self-compacting is there and self-curing is there, then you will achieve all the durability problems and it is going to give you all these uh, you can see the weight loss, you can see the X-ray powder diffraction, then all these things we can see what is the workability and all that. If you check all these, it is going to be very good in all that. So that's why nowadays almost it is came into practicality. maximum companies, they are trying to simply they are going to cast the specimens, and it may be internal curing agent or it may be external curing agent, like that they are going to use, and simply they are going to take the advantage of it. See, in all these cases, whatever we have discussed, whether it is self-compacting, self-curing, high strength, high performance, vibrated or environmental friendly, all these things are there. But the thing is, whatever you are saying, you are not able to completely avoid the cement. So now we have another alternative where you can get the complete replacement for the cement, that is called the geopolymer concrete. So for the geopolymer concrete, it is an inorganic polymer and considered as the third generation cement after lime and Portland cement. Because here what we will do is we are going to use this binder as a binder material. We will use the fly ash GGBS like this, and we are going to have the alkaline solution. So this is mainly comprised of tetrahydrals of AlO4 and SiO. Alumina silicates, alumina and silica. With these AlO4 and SiO4, with these combinations, aluminosilicates, we are going to prepare the alkaline solution. So for the preparation of alkaline solution, you can use sodium hydroxide or sodium silicate. We are going to have the alkaline solution. We are going to have the binder. So these two things are going to be mixed to develop the geopolymerization process, and that is going to be the give you here no cement hydration, simply geopolymerization. This alkaline solution is going to react with the silica content available in these binders, and from that you are going to the through process of geopolymerization you are get polymeric action, inorganic polymeric action. That's why we are calling this as a geopolymer concrete. And but when you are going for this, you should be careful. You have to use the gloves and all that, and you have to prepare the concrete, and it is a very good alternative. Already I told you, whenever you are going to say about geopolymer concrete, you use the locally available materials and use the even sodium silicate also. Nowadays from some industries it is coming as a byproduct. Directly if you purchase these chemicals, they are going to be costlier. Instead of that, if you use some industrial waste like sodium silicate and all these things are going to be having the industrial, they are also available as a industrial waste. So if you use these, then the cost is going to be very less. And nowadays in India, fly ash is very cheap, and you can develop the geopolymer concrete only by using the fly ash, or you can develop it by using fly ash plus GGBS and all that. But it depends upon where you are going to develop. Actually, what happens is this is the process: leaching, diffusion, reorientation, polymerization, and setting of monomers into polymeric structure. Once the polymeric structure is prepared, then this geopolymerization is going to be a heterogeneous reaction, and from this you are going to get this concrete actually. So for these alkaline silicates and sodium alumino silicate, and that means sodium hydroxide or potassium hydroxide, any hydroxide and any silicate, this is going to be combined with the binders. So from that you are going to get the geopolymer concrete. But the thing is, when you are going to prepare this preparing the concrete, already I told you these are the some superior properties sets at room temperature. That means no need of any external curing. Pani jaruri nahi hai. You don't want any water for curing. Simply at ambient curing only you can do. But it depends upon the whether it is ambient curing or it is elevated curing. It depends upon what type of binder you are using. That we will discuss. Non-toxic and bleed free. That means there is no bleeding chance, because whatever the chemical you are using now, it is going to properly react with the binders. No leakage like cement mortar or like that. Long working life before setting. it is going to have workability is going to be, it is going to be very much longer time workable condition and impermeable. Obviously, geopolymer concretes are going to have very strong about the impermeable and high resistance to heat and resist all inorganic solvents and higher compressive strength. They are going to have a very high compressive strength. But there are certain limitations because already I told you when I am going to use only fly ash, then you have to, because fly ash is not going to activate without any heat. So that's why even though some hydroxides are there, silicates are there, without initial heat, well, fly ash is not going to be activated. So that's why we have to activate it. It may be pre-activated or it may be post-activated. So basically, if I am using only fly ash, what we have to do is you can prepare this and you can go for a elevated temperature for certain time after preparing the concrete. That is also one method. Otherwise, you go for preheating of the concrete. So from the preheating technique, actually what happens is it is going to be when it is a preheating, no need to preheat all the concrete, only slurry is going to be preheated and that is going to be used in the concrete. So because of the preheating, already this is fly ash is activated and no need of any further curing, either any further elevated temperature is also not required. Okay, then similarly, we can use some fine aggregates could segregate all these things. Sorry. But in addition to that, what you can go to is actually we have the one patent related to this fly ash based technique, preheating technique, instead of going for post heating, because post heating means total structure is going to be heated and it is not possible in the site. Only it is limited to the prefabricated structures. So instead of that, what we have done is we developed a technique, preheating technique, and we have a patent for that. After that also, we developed one more technique. Instead of only fly ash, you use the combination of ash plus slag. So ground granulated blast furnace slag, then it is going to give you the ambient curing only, and strength is also very high. But only GGBS is not going to be suitable. That's why combination of fly ash and GGBS is always good for developing the. This is the preparation of alkaline solution, because you can get it sodium hydroxide or sodium silicate. Sodium hydroxide may be in the pellets form, sodium silicate may be in the powder form. Then that you can dissolve in the water, you can prepare the solution and you can add them to prepare the alkaline solution. Otherwise, nowadays from some factories, directly you are getting this as a byproduct. So if you get it as a byproduct, it is going to be very cheaper and you can prepare it. Already here, one thing is important. Molarity is very much important whenever you are going to say about the geopolymer concrete. So one example I have shown you here. Suppose if I am using a NaOH of NaOH, its molar mass is 40 grams, and if I am saying it is 1 liter, it is in 1 liter. If I am dissolving 40 grams, means it will give 1 molar. Similarly, based on your 10 molar, if I am saying 10 into 40, so 400 grams of sodium hydroxide I have to dissolve in 1 liter of water. So finally I have to get 1 liter of solution by dissolving 400 grams. Then it will be 10 molar. Like that, different molarities are there. Based on our requirement, we will use from 6 molar to 14 molar. But generally what happens is goes on, molarity is increasing, strength is increasing, but the problem it will come so that with the workability, and it is not going to harden early. Suppose if you go for 14 molar, 16 molar like that, it will take so much of time to come out to harden come out in from the fresh state. So that's why even though it will give good strength, but we will prefer only 10 to 12 molar only. After that we will not use. And these are the different methods of curing actually. Already I told you, if you are using the combination of fly ash and GGBS, you can go for ambient curing itself only. But otherwise, suppose you are not using fly ash and GGBS is not available locally with you, then you can go with the fly ash only. But the concept is you have to go for preheating or post heating, right? And nowadays in India, in some states, even fly ash is also difficult. So that's why they are thinking alternative for the fly ash like rice husk bagashi ash. That means nowadays rice husk is plentifully available, and again that you are using somewhere this rice husk or sugarcane bagashi, that is called from sugarcane uh, from the sugarcane you will get the sugarcane waste, that is called bagashi. That you are firing, you will get sugarcane bagashi ash. That is also nowadays, because in India sugarcane is the main crop and you are getting maximum of it as a waste. So after burning it, whatever the ash is, it is coming nowadays, it is a problem. So if you use that one as a alternative for fly ash or replacing the fly ash with some percentage, then it is a good solution. Similarly, GGBS also, if it is available, you can use the GGBS. Otherwise, you can go for the rice husk ash or some other slags also you can use. So these are the different developments. With respect to all these things, our aim is the sustainability concept. How we think in the direction of sustainability. Our aim is whatever, starting from the normal vibrated concrete to high strength concrete, high performance concrete, self curing, self compacting, even bacterial concrete is also one of the thing is there. But in that is used only in case of health monitoring concepts. When you want to close down the crack formed because of some problem or because of the some failure, the crack should be initially only if you close it na, then it will not create much disturbance to the structure. Otherwise, because of that, it is going to be, the damage level is going to be very high. So to avoid that, generally what we will do is we will use the some capsules will be there in the form of bacteria, and they are going to have the capacity of self-growing. That can be used in developing this self-compacting concrete. And so already I told you steam curing is there, ambient curing is there, preheating is there. So all these curing, steam curing means instead of using preheating, only fly ash is used in preparing the concrete. Then definitely you have to go for elevated temperature of steam curing. Then only you will achieve develop the geopolymer concrete. And you have developed all these concretes, okay, with respect to the concept of sustainability. Again, once again, I am telling you, see, in olden days, even though they have developed the infrastructure, they have gone for different monumental structures, even still after 400 years, 500 years also, they are giving service, but they are not harmful to the environment. But nowadays, what we are doing in the name of early completion and we want to, house means within 3-4 months, I have to complete one house. So if you construct like that, it is going to give you definitely you are going to face the problem. And for that, whatever the materials you are using, they are harmful to the environment. So that's why whatever the techniques you are going to use or whatever the materials you are going to use, it should be environmental friendly. So now here we will see some of the techniques actually what are there that we can see here. See, earlier only earthen houses are going to be constructed. So they are very much environmental friendly because nothing you are disturbing, whatever available in the whatever is available in the environment, simply you are using the locally available earth, and that only you are by adding some locally available things only you are preparing this mud as a binder, as a wall, as a construction element. And see the floor roof also, the waste from which is coming from the agriculture, that is used. So it is definitely a environmental friendly and sustainable. Initially, we started with these houses, but this also I already told you, when you are preparing these houses, minimum 18 inch to 24 inches, you have to maintain the walls. Otherwise, they are not going to stand because of their self weight itself. So thickness is going to be very high. To avoid the thickness and to have some temperature differences, we went to the wooden houses also. In some countries, they preferred the wooden houses. Total frame is wooden. Then after that, these wooden planks are used for the partition like that. Then after that, stone masonry. So they used the stone masonry as also one of the construction, because initially you started with earthen, then wooden house, then stone masonry. So in the stone masonry, they are using the stone plus sometimes it may be a mud, or sometimes it may be a lime mortar. By that time, lime mortar is came into picture. Then see, when you are going to use this earth and all that, they are not going to have proper size and all that. But stone is going to take very big size. Even with when you are preparing a wall with the stone, minimum it should be starting from 14 inches to 20 inches, 18 inches, 24 inches like that. So the wall size is going to be very high, and you have to make them usable for the construction. Then only you have to use that stone. So it is time taking and hard to work with the stone. So that's why next what they have used is they developed this brick masonry. So where in the brick masonry, simply what you can do is, by utilizing this brick masonry, burnt bricks. Actually, what you can do is you are preparing the bricks and burning them. Because of that, they are going to give strength. And with this, even with a small cross section of 9 inches or 4.5 inches, also you are able to construct the walls. And after that, we went to the confined masonry house. That means, along with the bricks, you are going to use some steel reinforcement. This is the first confining means. Along with the steel brick work, you are going to use some confinement as a steel, so that it will give long durability and sustainability. So that's why, to make a more ductile construction, we introduced the steel in the structure. That is the uh, confined masonry house. Then after that, actually, we went to the RC framed structure. So after that, in RCD framed, what we are doing, we are first preparing the complete RC frame. Then along with that, we are going to prepare the partition walls. So like that, we are going to finish. But all these cases, it is going to be time taking. So that's why, again, for this reinforced cement concrete also, we are thinking different alternative or innovative construction techniques we are using, like replacing the conventional framework with the new formwork system. Instead of going for separate footing, then columns, beams, slab, then partitions, instead of that, completely you take formwork, you prepare the total building formwork at a single time, then you fill it with the available material. So like that also, replacing the conventional formwork with the new formwork system, or the brick mortars are going to be replaced with the sandwich panels, because brick mortar is used for preparing the walls. Instead of that, if you use the sandwich panels, ready-made sandwich panels, or preparing them at the site, they are going to give very much advantage. Instead of cast in situ RCC, you can go for a steel frame because ready-madely available. So like that, even precast is also one of the solutions. Nowadays, if you see, all these are the precasted walls, precasted doors, precasted windows. Even staircase is also now available precastly, and just you have all these in the sprite, and you are assembling them into a single property. So like that, you are going to use this precast construction technique, and after that, we are going to have basically this precast construction for low cost housing, completely taking from the partition walls to roof to doors, windows, everything can be prepared. and IIT Chennai has prepared GFRG panels. So directly these panels can be used as a, see here, this is used as a slab. Similarly, this can be used as a wall. So like that, it is used, even you can prepare the staircases also. So like that, you have to develop. And now after the precast concreting, see precast is also, there are certain limitations. We're going, nowadays we are thinking for a 3D printed concrete. This is the latest technique. Whatever the advancements there in the material and whatever the advancements are there in the techniques, we are going to combine both these and we are going to develop a 3D printed concrete. And I am going to have one more session tomorrow. So in that, detailedly, I will explain you what is the advantage of 3D printing concrete, how to prepare a 3D printing concrete, how to prepare a main problem with the 3D printing is the additive what you are going to use. That is the mortar what you are going to use is very costly. So instead of that, you are able to develop that additive by yourself in your laboratory. Then you are able to develop this whatever this robotics is there, whatever the software it is there to prepare this 3D printing technology in 3 dimensions, X, Y, and Z. You have to know the programming and all that. If you develop all these indigenously, that means we develop all that in our college itself, then it is going to be automatically economical. So much more about we will discuss tomorrow about that. But simply I can say what are the special features. Design freedom. You can design any design. There are no limitations on the shape and size. Then construction efficiency, because once you are able to develop the economically friendly additive, it is going to be very efficient and there is no wastage and prefabrication is available, and in the site also you can prepare even in case of emergency cases, in disasters, all these cases, this 3D printing is going to be help you very lot. And automation, because one model you have prepared and you are saying this is passed, then any number it will prepare within fraction of, that means within no time, with a very less time only you can get more number, and there is no need of any farm work, and it is going to be very safe with the farmers, with the laborers actually, sorry. And another alternative technique what we proposing is composed of multi-story structure. See here, what we are suggesting is by the whatever the developed geopolymer concrete is there, any other concrete is there, which you have developed for the as a sustainable infrastructure development, that you use as a framed structure. Then after that, if you see the staircases, partition walls, and all these things which are replaced, that you can use as a bamboo based one or any locally available based one, because the problem with the bamboo based construction is all of you know that bamboo is a biodegradable material. When you are using initially it is available, but nowadays we are having boron coating and all that. We can improve the life of the bamboo, but it is not as much as longer life as concrete. So that's why after 10 years, after 15 years, obviously we have to go for replacement. That's why, because what the main structure you are not able to going to replace. So that's why you go for the main structure with the geopolymer concrete or some other environmental friendly concretes. Then the partitions like floor, walls, roof, or windows, door frames, all these you prepare with the this bamboo or some other locally available materials, so that it is going to be very environmental friendly and economical. Then these are the some of the applications whatever we have discussed till now. All these are used in housing of construction in different places. Whatever the new technologies we have taken, that BMTC is what it is doing is directly it is implementing. See, one thing you have to do is whatever the research you are doing, that should come into practice. For that, what you have to do? You have to go for trials, you have to go for having MOUs with the different agencies, and you have to develop this concrete, and it should be implemented somewhere. Without implementation, you will not succeed. And these are the some of the patents available with me for developing the geopolymer concrete. And for one, I have a Australian patent. I have a Indian patent. Actually, whatever the difference between these two, I can tell you. One is the regular geopolymer concrete I have developed. Another one I have developed environmental friendly. In that case, what I have used is even I have replaced this fine aggregate with respect to available locally available material like quarry rock and all that. Because in our area, the main problem is with the fine aggregate, it is very fine and you are not going to get any coarse content in that. So because of that, it cannot be used. If it is the fine aggregate is very fine, then it is going to have very high water absorption and some type of mud or what you can say, this soil particles are there. If soil is mixed with the concrete, it is going to create a durability problem. So that's why you have to use zone 2 sand only. It should not be very fine, zone 3, zone 4. So I have given an alternative solution. So that's why these two different patents are different. And I am going to show some of my publications. So before going to that, again, what I want to say is, whatever the techniques I have shown, what you think is, because till now I have guided four and fifth one is submitting. So first you identify any local problem, because why I'm saying, I started working on self-compacting concrete. Okay. So in NIT Warangal, but when I started at that time, we are facing problem with the availability of the coarse aggregate. Sometimes coarse aggregate is very high costly and it is so, and again, because of after it is completed 30, 40 years, we are demolishing some old structures and we are constructing new. So the demolished waste is we are throwing outside. And another thing is, in the, how many whatever the MTech students, PhD students, all the work they are doing in the lab, after doing that destruction, we are going to see. We are going to have the so much construction demolished waste. You are not utilizing that. So with that also, we have developed this self-compacting concrete by utilizing the recycled aggregate also. So here, my aim is to give a local problem first. So there is a problem availability of the coarse aggregate. I try to give a solution, and along with the locally available material, I have the developed the self-compacting concrete. Already we have discussed, because if you see the development from vibrated concrete to high strength to high performance, self-curing, self-compacting, everywhere cement is the main. You are not replacing the cement. So that's why now we are thinking the geopolymer concrete. And another thing is, if it is self-compactable now, then it is automatically it is going to give the good results. So when I am doing my research at that time, I tried to develop only self-compacting concrete. But afterwards, when joined here in NIT Silchar, then here we are going to get the zone 4 sand. We are not getting zone 2 sand. Then I try to have a solution to the locally available material. And because in this is in the earthquake prone area, so I planned my scholar problem in such a way that it will give a solution to the locally available problem. So locally is, there is a scarcity for the zone 2 sand and there is a problem with the material available. And so that's why, and already I have developed the self-compacting concrete. And another thing is, here it is in the earthquake prone area. So that's why not only static loading, we consider the dynamic loading also. And we tested the beam column joints under the actuator. So earlier I worked with the same self-compacting concrete, but coarse aggregate is replaced. Now here in this area, fine aggregate is a problem. So I developed the self-compacting concrete with the fine aggregate. And along with that, because it is comes under the earthquake prone area, so not only static loading, we checked under the fatigue for beams, flexural beams, and for beam column joint under earthquake cyclic loading. So like that, after that, see again, my scholars worked on geopolymer concrete. So already I told you, only replacing cement is some percentage of cement is not the solution. You have to think about the long-term solution. So that's why we developed the, again after this, we developed the geopolymer concrete. But when I'm going through the literature review, what we found is when you are developing the geopolymer concrete with respect to fly ash, definitely you have to go for after that we have to go for a steam curing or elevated temperature. So that is not practically possible in the site. Only prefabricated elements only you can do. So with that problem, we try to give a solution, and we found a preheating technique. Only slurry can be preheated. No need to go for all the concrete. So it is very small quantity when you are small quantity when you are heating it as a slurry only. So that's why in that way we are developing this, and I have given a solution. So for that, one more scholar is guided, and we got the patent also. Then still after that, so this is also not a solution. Preheating or post-heating means you have to go for heating. So that in all the cases it is not possible. Then we have another solution using fly ash plus GGBS, so that no need of any external curing, only ambient curing condition only you can utilize. So in that way, we have developed a concrete where no curing is required, and no cement is required. That is the geopolymer concrete. After that, see, now still what I am working, just I will tell you, after developing the geopolymer concrete also, again, from the beginning, in India, we are having the problem with the fine aggregate and coarse aggregate. So why not these fly ash can be used for developing the artificial aggregates or synthetic aggregates, we can say. So by using this fly ash itself, because sometimes getting the aggregate is very much tough. So in that cases, you have to go for manufacturing it. So now we are working in that direction, developing the aggregates by using these industrial weights itself, by using geopolymer concrete also, or geopolymer mortars, or geopolymer paste. Actually, geopolymer paste is different, geopolymer mortar is different, geopolymer concrete is different. Paste means only alkaline solution and binder that is going to be used for developing this. Actually, in the development of aggregates, centering is there, then cold bonding is there, then compaction is there. In centering, what happens, you have to go for elevated temperature, and in cold bonding, no need of that. So combination of fly ash and GGBS is useful, or compaction is also one of the method. So by going for compaction also, you can develop these aggregates. So like that, whatever the problem you are going to work out for your research is, it should give a solution to the local problem. It may be a sustainable solution. It may be a innovative infrastructure development, but at the same time, you have to give a solution to the locally available problem. Then your research publication or your patenting, or it is very easy to get patenting or publishing, because you are giving a solution to the existing problem. Na? So automatically you will, your research is going to be succeeded, and you will get the good publication. You succeeded in the patenting and everything. The product should come out, and it can be utilized in the field. That is the final motive of doing our research. Okay. So that's why all of you, what I can say is, you, as because we are the creators, Brahma, Vishnu, Maheshwara, like that, we are the Brahmas. We are creating, see, in the world, starting from the electronic, mechanical, civil, all these, all the engineers are innovating all the new things. But wait, whatever may be the innovation, you keep in mind that it should not harm the environment. I have to think with respect to sustainability concept. Whatever the God, whatever he is given the facility at free of cost, whatever we are enjoying now, that we have to give our future generations, grandchildren to grandchildren also. Now you see in Delhi, what is the problem? Even now this time, the pollution index is very high. Even after 5 or 6 years, you cannot roam in Delhi without your oxygen cylinder. That situation is going to come. So we have to avoid this. As a industrial, in the name of industrialization or in the name of infrastructure development or in the name of smart construction, we should not destroy our environment. Whatever the material you develop, whatever the technique you develop, it should be environmental friendly, economical, and locally available material you have to use. In that way, you plan your research, then definitely you will succeed, and easy to publish, easy to patenting, and easy to go for MOUs, and easy to go for starting a small startup and all that. So you go for alternative bricks which are prepared with the using fly ash, or prepare the aggregates which are using the waste materials, or prepare the prefabricated structural elements by using these all materials, then automatically you can start a startup center. So in that way, you have to do your research. So there is a very much high scope to do the work. But the thing is, you think in your locality what problems this society is facing, and in some cases landslide problem will be there. In some cases, there may be problem of availability of the fine aggregate, availability of the coarse aggregate, or some conditions, environmental conditions are very bad, like that. You according to your, or it may be earthquake prone area, or like that. Based on that, you have to give a solution which is going to be practically useful. Then this research what you are doing, and automatically you will get the succeed. But the thing is, nowadays simply you people are saying civil engineering means we are not getting the job. It is not like that. You give me the assurance that you, after studying 4 years, you are able to design a single building, one 2 BHK house. As a student, if you are able to design on your own, by using your concept of strength of material, concept of analysis, concept of the design, concept of estimation costing, concept of the plan, concept of soft computing. If you are able to design on your own by having the grip on the codal provisions and all that, definitely I am ready to give you the job. That is the situation nowadays. The students, those who are available now, because even I am attending so many interviews for taking them, they are not as strong with respect to their basics, and they are blaming the civil engineering. It should not be like that. You have the strong base on the civil engineering. Along with that, already I told you, now you have to work smarter. You have these new techniques, you learn the smart soft computing techniques, because nowadays even civil engineers also, no one is going to use manual analysis, manual design, or manual things. All we are depending on the soft computing, internet of things, and artificial intelligence. So you should be thorough with this. Automatically, along with your subject, you should have a grip on the soft computing or artificial intelligence or some other things, so that you can achieve your success easily. Without this smarter work, even if you have any because nowadays, see, only if you are working on the concrete itself in the macro level or micro level, nowadays people are seen the depth of durability, depth of microstructure analysis. All the papers are available. The existing literature, existing research is durability studies also finished, microstructure analysis also they are going into do deep. Now only available is, you utilize these whatever the technique you are developing, you adapt along with that some soft computing or some internet of things, some artificial intelligence. Suppose if you are thinking, you think, because in India we are having different disasters, you prepare the disaster mitigation techniques, You prepare a solution for the floods. You prepare a solution for the fire accidents. You give a solution for the these landslides, or you prepare a solution for the earthquakes. Whatever the product you are going to give as a civil engineer, you use it with the concept of this drone technology, with the concepts of artificial intelligence. Because nowadays, even if you see the e-business or anywhere, now we are very much. Best example, I will say, suppose you are searching for a flight from some place to some place. Let us say from Bhubaneswar to Delhi, I want to go. You are searching a flight, but you have not booked the ticket. You see, you are going to open your Google browser, or if you are opening your Facebook, or you are opening your Twitter, anywhere, the ad they will show from Bhubaneswar to Delhi, these flights are available. This much percentage we are going to offer. How they are going to, because that much of uh, technique they are using in the e-commerce nowadays. What is your requirement? Based on that, they are coming to your doorstep. Even if you open a Facebook, it will show relevant ads. You observe. Otherwise, the ads are different earlier. But after once you are searched a flight from Bhubaneswar to Delhi, then you will get all the relevant ads related to that. Similarly, if you try for a train, it will show relevant IRCTC and all that. Even if you are suppose some devotional you have searched in the Facebook, then you see the next whatever you are going to get the upcomings are almost 4 or 5. You see that scrolling also, even in the your Twitter, or even in your Instagram, or in your the relevant data only it will come. So this is all possible only because of big data, artificial intelligence, machine learning, all these things. So similarly, in our civil engineering field also, we have to work smarter, not harder. The concept you learn and you implement it with the soft computing, or with the IoT, or with the artificial intelligence. You have to upgrade yourself. See, only computer engineer nowadays, he is just a data operator. But as a civil engineer, you have the subject knowledge along with the soft computing things. No replacement is to you. I can replace a software engineer. If I hardly work for 2 3 years again, then I will become a software engineer. But a software engineer never become a civil engineer, because civil engineering means you have learned 48 subjects. You have all the different ideas, different areas, and basic knowledge. Then you are moving in a different a specialized area by doing masters and all that. Then research means again in a focused area. So you are very strong in your subject. At the same time, if you use work smarter, then definitely you have a success. So what is my sincere request is, in private colleges also, faculties, but they are generally what happens is, for civil faculties particularly, because they have only one section, and all other computer science or some other branches, they are going to have 6 sections, 7 sections. So that's why, particularly if you see for the civil faculties, you are going to get a, not relevant work. You are going to do the examination branch work, or they ask you do some other accounts works, or some NBA work, or NAC related, all these things they ask, because you sufficient volume of work they want to try to give. So instead of that, if you have this soft computing techniques, or Internet of Things, or writing a MATLAB coding, or Python coding, if you have a command on these, then you can demand them, sir, I can teach the one Python programming, or I can teach a C language. I can give a MATLAB coding, because when you take a numerical methods in engineering, it is common for all. So if you have a command on the soft computing, you can teach a numerical methods subject for any branch, or you can teach a Python programming for any branch. So in that way, you are in civil also, you are going to have the demand in, and by learning this soft computing, In other branches also you are going to have command. So in that way, they will give you preference to you. Otherwise, in hard times, they will say you go out. Instead of that, you have to create your identity. They have to come to a identity that no, this person is having smart techniques. So he can be not only used as a civil engineer, he can be used as a program writer, coding writer, artificial intelligence, then disaster management, or even in all these cases, build even BAM software is there. That also we have to learn. Not only civil engineering materials, particularly we should have the grip on these management side also. We have to learn the softwares like program this Primavera, then BIM, uh, building information modeling. All these things you should upgrade. Then only you will get the demand. Okay. So this is the application and these are the publications what I have done, and this is from my side. So I have crossed the limits. That means instead of my topic, I have told you so many things because by thinking that all of you are civil engineers and I have very much love related to the civil engineers. I want all of you in good position, and always I want to get a demand for the civil engineers. Definitely in the upcoming years, there is going to be huge demand because the thing, same thing, what I am saying is along with your subject, you should be strong with the soft computing skills also. Then there is no replacement for you. With 2 years experience, now suppose you are getting 25, immediately it will jump to 50. Then 50 will jump to 75. 75 will jump to 1 lakh 20 like that. The salary. But the problem with the civil is initial days. In the beginning days, we have to work hard. It is not that much easy to struggle, settle first. But opportunities are so many opportunities. Even my students, MTech students, PhD, none of them are not waiting for job. They are doing their jobs. The thing is, not only doing the MTech or PhD, along with that, they are learning the soft computing skills and they are implementing what they are. Any research should come into the practical field. Then only you will get the benefit. So this is from my side. Thank you. Thank you giving an opportunity, and whatever the ideas I have that I have shared. Sorry if I have tell anything wrong, and thank you. Thank you for giving this opportunity. Thank you, sir. Pankaj, sir.
Yes, sir. Thank you. Thank you very much, sir.
Yes.
So, participants, if you have any question, so
Yeah.
you can just
Please.
discuss with our sir. Any question from participant side?
If you have any questions, please you can ask freely. No problem. Just we will discuss. If I know, I will tell. Any general question or relevant to your publication, relevant to your research, any general question also I am ready. Not only concerned to the topic. As a civil engineer, you have any doubt, you can ask. Otherwise, I will share my mail ID here with organizers. Anytime if people be in contact with me. But what is my suggestion is whatever the work you are doing, you love that work, sincerely you learn the things and adopt the soft, smart working nature, not hard working. No need to work harder. We have to work smarter. Then you will see the success. And definitely, because nowadays the generation is everyone wants to give a job, not waiting for a job. So for that, institute innovation councils, so many things are there, startups are there. Startup means for civil engineers, it is very easy to go for a startup. You take some any product, small product, you develop some bricks, you develop some aggregates, you develop some any type of new thing, then you go for starting a startup or you go for a design consultancy like that.
Yeah.
Yes, sir.
Yes, thank you so
Good
much,
evening,
Doctor.
sir.
Yeah, good
I am,
evening.
I am having a question.
Yeah, please.
Yeah, no, Dr. Prakash,
Considering
have you said that?
environmental friendly, can
Yes.
we replace sand by sustainable material?
Yes, sir. Actually, see, from sand from where you are getting from the river, and it is a natural resource. So continuously you are deploying the sand. One day it will come to the end, and because you are removing the layer in the river, so the water storage capacity is also reducing because sand layers are very much useful for your groundwater. This is a very big problem when you are continuously using the sand. So obviously, we have to develop the alternative for sand. It may be a quarry rock dust, waste from the quarry rock, or you can manufacture the sand, or you use the foundry sand. Now I am working on the manufacturing of alternative sands manually by using this fly ash and all that. And it is a very good area. So please work on that. And you definitely you have to go for replacing the sand.
Thank you, sir.
Right.
Yes. Can I have second question, please?
Sir, I having a question, sir.
Yeah.
Sir, in civil engineering, attaining sustainable development goals,
Mm.
what are the roles and can we achieve both environmental and social benefits?
Yes, madam. See, sustainability means already we have discussed. Sustainable means it should not give any harm to the environment and whatever the facilities now, let us say now sand is available in the river. But if continuously I am using this sand of next for the 10, 100 years, 50, 150 years, then next generations they will say once upon a time they are going to use the sand. It should not come. So, sustainable development means we have to use the natural resources in such a way that these should be given to our future generations also. Best example I can say now at 10 rupees you are getting a half-liter bottle. You maintain this at least after 200 years also with a minimum price you are able to get the water. It should not be like that whatever the salary you are getting in that 25% is going for your purchasing of water. It should not be like that. So that sustainability development we have to do at the same time environmental friendly. Why environmental friendly means without environmental friendly sustainability is not available, and environmental friendly will help you in sustaining this environment like replacing the cement, replacing the natural resources, thinking the alternatives. Even nowadays for electricity also we are thinking the alternative, na? Uh, so like that, solar systems, then we are using different renewable energies, na? So like that for our materials also we have to think the alternatives which are going to be sustainable and environmental friendly. Environmental friendly means they should not create any harm. Suppose I developed some product and it should, best example you take, these plastic they have developed, but plastic is so much creating the problem nowadays because the reason is it is not a biodegradable. See, earlier days what we are doing, we are taking the chai in some earth, that cup what it is prepared by mud, but that is after using it if you throw it immediately within 1 month or within very small time only it is going to mix with the environment and again you can use it. But if I throw a plastic bottle it will take minimum 200 to 400 years to change its plastic tape to natural. And if these plastics are consumed by these animals, again cancers, 90 to 80 to 90% of the cancer diseases coming in India is because of this utilization of this plastic. See, everywhere we are, whatever the teacup we are using also, inside also they are going for a plastic coating. Even better don't use any plastic coated teacup also. It should be paper means pure paper only, no plastic coated. That microplastic, because you are using a very hot liquid, you are pouring in that. So when it is going small nano or micro level, they are going to mix with this liquid, they are going to inside, then it is going to create a cancer. And even when we are going to the market, try to utilize your olden days one cloth bag, try to utilize one example. So environmental friendly means what you have to do, you use this waste because you know what is the problem with the plastic. You utilize this in developing any product. You utilize this waste, and from that you develop any product, so that it can help you in developing the environmental friendly material. Like that, you have to think, right?
Okay, thank you, sir.
Thank you.
Thank you for your valuable talk. So, and we are eager to listen another session from you.
Yes,
So
sir.
again,
Tomorrow.
I thank you, sir, for your valuable time.
Yes.
So now, with your permission, we can close the program.
Yes, thank you. Thank you, madam, for organizing this. And tomorrow we will go to the 3D printing technology, because nowadays everyone is saying about 3D printing concrete. So how to develop that? What is the advantages? What is how to prepare the additive? How to prepare the laboratory level 3D printed concrete? That we will discuss tomorrow, right?
Okay, thank you, sir. Thank you, sir. Again, good night, sir.
Thank you. Thank you. Thank you. And thank you very much for the organizing team. Mosami Madam, Mohapatra, thank you very much for sharing all these links and all that. Thank you, sir. Thank you all.
Okay, sir. Okay,
Good
thank
night.
you. Thank you, sir.
Good night. Good night.